that this is being recorded.
Careful what you say, man.
Yeah, well, so, and just for the group, my son, Joseph is gonna join us at 11 o'clock. He's just finished his undergrad in architecture at Kent State. So thank you for allowing him to just be a fly on the wall. He's 6'8". He knows that he's 6'8", so you don't need to comment to him. But again, I'm just really excited to be able to hear the thoughts that you have about this building. This building was one of the reasons that I came back to Northeast Ohio, and certainly one of the reasons why I was elated to be able to join the team in Oakland. So thank you.
Why can't we comment on his height?
I'm Cindy France. My tag says I'm Cindy McPherson. Don't worry about why. I'm a faculty member here. I'm an environmental psychologist. I chair the Committee on Environmental Sustainability, the faculty committee that oversees the implementation of our environmental policy. I've done a lot of research over the years with John and with Rumi on the dashboard system, which was originally, it was originally designed to illustrate what was happening in this building, and then since it's been expanded across campus and into other cities. I think that's all I need to say. I am not 6'8".
And by the way, if we all use about 2 minutes of time, we'll be on Cindy 38 seconds. So that's a good model.
You're welcome.
My name is Ben Hobbs. I'm the facility manager and community outreach coordinator for the building and the program. I actually came here out of secondary education. So I was a high school chemistry and environmental science teacher for 10 years and then spent 2 years in the solar field before coming here. My main responsibilities here center, well, there's lots of them, but the ones that I'm trying to see this through the lens is both as a facility manager, right? So having the responsibility of making sure that the building functions as well as possible, but then also I run the living machine with essentially anywhere between 8 and 15 students, depending on the time of year. And their interaction both with the building and the annex next door and the lab and just how important they are and how important this building has been to them historically, really informs that lessons. So I'm super excited.
Yeah, swinging out to the edge. Okay, so I'm Kevin McManaman. I am the guy who ends up actually implementing these end plans and buildings. I own a controls company and also started a software company that builds simple UIs for the front end of control systems. I've been involved in just around $375 million worth of controls projects in downtown Cleveland. So if it's a tall building, chances are either our software is running it or I've done some sort of engineering for it. I got involved with John because we did a joint project at the Cleveland Foundation, setting up the ability for our devices to acquire data from the existing control system there and then provide that to community hubs so that they can display what's going on there. And we're looking to set up a similar scenario here, but John and I had a couple of conversations and I became really enamored with what's happening here. So I'm here to offer my time and expertise, to help make sure that implementations go smoothly and do whatever I can to help with engineering. And I'm super interested in, what we can do moving forward to make things more efficient. I've watched the inefficiencies actually occur as the boots on the ground person in the field. And so I'm excited to work with everybody here. I think there's a lot of opportunity.
Hi, I'm Rumi Shaman. I'm a professor in environmental studies, and this building and David are among the main reasons why I chose to come to Oberlin. And my doctoral training is in urban planning and design and energy analysis. So in that vein, I teach courses on energy and society and urban sustainability, which focuses on urban design and planning and energy systems and renewable energy and all of that stuff. So this project is really very exciting for me, and also I see my courses to interact with the outcomes of this project in many different ways. When I was at U of I pursuing my doctoral studies, I had the pleasure of being in a I think it was some kind of a workshop with Bill McDonough as a student. So, that was my orientation to Bill's work back then.
Sure, thank you.
Yeah.
I'm Russell Perry. Spelling Russ with one S actually, but who cares? Kevin Burke and I worked together at William McDonough and Partners from 94 to 2005.
Yeah.
Kevin continued on. I went on to direct the sustainability effort for a large national design firm until ending my career a little while ago, and I'm retired. So I'm coming out of retirement to join this. Obviously, this was a seminal moment in my career. I was doing this with Kevin at the same time that I was involved in developing the lead system for US Green Building Council. So this was informing that work, and then I was able to conclude my practice with the project for the Chesapeake Bay Foundation, the Brock Center, which was one of the first living buildings on the East Coast, which is we're going to hear more, hopefully much more about living buildings as we go forward. A real pleasure to be back. It is said that anyone can be best, but only one person can be first. And I don't know anybody who has taken on the task of recommissioning a 25-year-old high-performance building. I think this is the first, and should be taken very, very seriously. So thanks for inviting me here.
I'm David Orr, I'm Russ's parole officer. I am currently professor of practice at Arizona State, working mostly on issues of climate change and democracy. I'm here as an observer.
You get to know this guy after a while, well, it doesn't take long, really.
You want me to say more?
All right, I'm Lindsay Baker. I am the CEO of Living Future. We run the Living Building Challenge. But more importantly, I came to Oberlin in the year 2000 because I heard about this building, and it opened my first week of college, and influenced my career in a million different ways ever since. I worked on LEED standards when they were first coming out and became a building scientist. Went on to work with Google. I started a controls company with some folks, did a lot of different things, trying to figure out how we leverage small actions to change the global building industry. And I'm still doing that work today through Living Future, where we certify buildings, but we also work on a lot of things around materials and how they're made, and firms and how they're organized. And we're a thriving 40-person nonprofit all around the country, working with people all around the world on buildings a lot like this. So it's been kind of a thread through my career to think about and work on how buildings like this learn and change and do their best work to influence the communities around them and the larger systems they're a part of. And yeah, super happy to be here.
I'm Nicholas Coughlin. I'm a current fourth-year environmental studies student here at Oberlin with a concentration in environmental and ecological design. And I, along with Josette and Sammy, have been running the envisioning sessions. We've talked to close to 100 different alumni and various people in the design field to prepare for this meeting and basically summarize what this building has done, what it's meant to people, and where they see it going.
Very cool. I'm Walt Galloway, class of 1969, that is, Oberlin College. This building, I was going to say probably hadn't even been thought of, but that's probably not true. Probably people had thought about it, but it wasn't here. And environmental studies wasn't here. And I was a chemistry major and ended up through weird circumstance, ending up as a chemist, which I thought I would never do while I was studying for the Environmental Protection Agency. And I continued there in various roles, seldom being a chemist for 38 years. And I do a lot of stuff with the Alumni Association and have for years. And right now I chair the group that's called Enviro Alums. And so in that role, I've worked a lot with David and John in all different ways over the years. And this building, I think it's really interesting because I don't have the same connection with it that a lot of you have. I just have come here over the years. And so I'm still trying to figure out what that actually means because it's simply a building. But it's not. And so, how to fit that in to this whole thing, I'm really, really glad to be here and that John asked me if EnviroLums could be involved, and I was like, well, how could we not be involved? So, thanks.
And I'm Kevin Burke. I'm a principal with Parabola Architecture in Charlottesville, Virginia. That started with my wife, Carrie. After leaving practice with William McDonough, worked there for 16 years and kind of inherited Russ's position of managing the practice in 2005, 2006. The experience here certainly changed my career, changed my life, and prepared me for what I've had the good fortune to be on a number of projects during the time at McDonough's and then subsequently working with Carrie at Parabola on projects that were super ambitious in their goals and objectives and wanted to be their first or most in some realm. Projects with NASA, interacted with Lindsay at Google during the day as they were looking to scale up, and we did both global design guidelines for them at McDonough's and then at Parabola, and ended up designing Google's first ever ground up building to prove that they could build something with their goals and standards cost effectively in 22 months or some crazy schedule and all. So I'm really fascinated with the notion of how do these things happen. It's more than just high performance, but thankfully had the chance to work on high performance buildings. It is that ecosystem of how organizations and the entire team gets in stride to make something ambitious work. And had great experiences and seen the times when sand gets in the gears, as David would say, and times when things can really go smoothly. And when they go smoothly, the spirit and energy of everybody involved can really get imbued in the built artifact. You can feel it, and that endures. So that's what still moves me. And I was just so excited for David to invite me back and to re-engage with Russ and to have this chance just to be part of what's going on here. And also hi to Bill, if he's still there. I don't know, he might have jumped off, but it's great that Bill is great that he's in the room, and really good to see you again.
Bill, maybe you should introduce yourself since you've just been introduced.
Hi, I'm Bill Browning. I'm the thorn in David's side. I was at Rocky Mountain Institute working with Amory on starting a buildings practice around the time that David was thinking about initiating this building. I'm now a principal in a small firm called Terrapin, Bright Green, and a lot of our work is really trying to figure out what the ecosystems are telling us about what we should be doing in those places related to the built environment and how the built environment impacts people physiologically and psychologically.
I'm Josette Apple. I'm a fourth year at Oberlin studying environmental studies, really interested in environmental communications and urban sustainability. As Nicholas said, I've been working alongside him and Sammy. He summarized what we're doing pretty well. But this has just been such a wonderful project. We've been doing this for our winter term, and I'm pretty sure Nicholas and Sammy are going to continue after while I work on the Science Center display case. But it's just truly been incredible to hear what alumni and current students have to say about the AJLC's impact and what they think it could be in the future. I'm really excited to be here with you all today.
Yeah, I'm Sammy Singleton. I'm a fourth year at Oberlin, also part of the student team. Yeah, I'm interested in urban sustainability and green design. So this is a super great opportunity and really excited to hear more of all your ideas and be a part of this.
Hi, I'm Joe Kumar, Director of Capital Improvements here at the college. What I'd like to say is like what we do with Chris's help, his staff and our staff and facilities planning, construction, and Kevin Brown, who's my boss, work to really take the institutional priorities and really train what goes into the bricks and mortar that you see around here. So, with that is a lot of process and just, getting down to the nuts and bolts of how do you execute a program. And so that's like where my focus is, and making sure it's in alignment with all the other campus priorities, campus master plan, where we're building next. This is an exciting project. When Ben, we talked about this, last few years, and, there's a litany of things that we need to focus on in this building, but I also would say there's other areas of opportunity here. So it's great to see everybody here to really focus in and hone in on that, and an opportunity to kind of move this type of structure forward, and then really try to multiply that across the campus. So, thanks.
So I guess I didn't quite introduce myself, and I'll go ahead and do that. I think most of you know me, but John Peterson, I was a student here in the 1980s at Oberlin College. I think one of my proudest accomplishments here is I am a co-founder of the Oberlin Bike Co-op, which is still here all these years later. I came back, David Orr hired me in 2000 to be a faculty member here. I had the distinction of being the first faculty member to move my office into this building in early January of 2000 when this building opened. I'm an ecosystems ecologist by training, so I have a degree in forest hydrology, but also a degree in marine ecology, so both terrestrial and aquatic ecosystems. McDonough and team had really conceptualized this building as being organism-like or ecosystem-like, a lot of the sort of analogies you guys were using. And so arriving as someone who didn't yet have a lab here to this novel ecological entity, I set about to instrument the bejesus out of this building. So in the first couple of years working with the National Renewable Energy Lab, we installed over 150 sensors throughout the building and landscape to monitor flows of energy, flows of water, just resources in general, conditions within the building, conditions outside the building. We measured soil moisture, soil temperature, that sort of thing. Because, as I say, the building was conceived of as an ecosystem. I've been involved in instrumenting ecosystems to study them. And really that was a complete turn in much of my career, from focusing on complex feedback in dynamic natural systems to complex feedback within the built environment. Cindy became a research collaborator early on because while plankton, work based on basically light and nutrients, buildings work based on people, and what controls people is social psychology. So that's different control mechanisms. Same idea though, the question, can you provide people with feedback within buildings that allows them to better understand their roles as agents acting within that, and hopefully ratchets up their behavior in a way that improves the performance of buildings. And maybe still a question that we're asking, inspires people to act differently outside of those buildings in other parts of their life. So been involved in developing a lot of the dashboard technology that many of our students have worked on and developed careers out of, and working very closely with Cindy on studying the impact of this technology, not just in buildings now, but in whole communities. Trying to reconnect people with nature. Can you use technology to, can you translate technology into a form that's easily accessible to a non-technical public that allows them to engage in pro-environmental, pro-community behavior? Can you actually use this information to inspire people to be better stewards of the environment in general? And I'm just so humbled by all the people in this room. We have a lot of expertise, a lot of knowledge, a lot of history in this room. And I'm super excited about, deeply thinking about how we can, do what Joe's talking about, take what we learn in this building, use this as a process to learn things that we can then get out there. I think we already have done that, but in terms of a lot of the sort of, especially the psychological components, how can we get the whole campus, thinking this way? So really appreciate being here. I'm going to point out that we're already a little bit behind schedule. Russ and my students are both charged with keeping us on schedule. The one thing I want to draw you to most is the 10:30 time when we have Mark Brune zooming in, because that's a fixed time. So we need to shorten up our next two so that we can get to 10:30, because we've got one little window of opportunity with our star mechanical engineer on the project. Mark Brune, who's going to be coming in at 10:30. So I leave it to the people who know that you can keep us on that.
All right. So John and David have asked me to facilitate this meeting, something that I have not done now for several years. So we'll see how that goes.
It's like riding a bicycle.
Yeah, I think so.
Yeah.
So who is taking notes here?
We are actually, these guys are assigned note-taking duties on
Good.
each one of these, so that's a thing. We are also creating a transcript of this
Okay.
and a recording.
Good. So the process today is to go through list of systems in the order that's been outlined here. Each of the systems has a champion or two that have been assigned, not selected by individuals, but John has said you and you. We ask that as we go through each of these, that the people assigned to lead that topic spend 5 minutes or so to summarize what they know and what they read and what observations they have, and then to lead a conversation about that. I don't know everybody in this room, but I'm confident that everybody will help us that we can work together to keep our timing by being succinct and not adding things that aren't particularly relevant. As we get into conversations, Lindsay has suggested that we use these as a way of indicating that I have something to say that I would like to add. So let's do that if you want to add, and then the people who are leading each of the sections can then call on you, and we can go from there. So just by way of, this is so awkward. I haven't had this many pieces of paper in years. But it's really useful for reading in the plane. As we go through, let's keep in mind in one of the last page of the document called On-Site Charette is the agenda for Saturday. I think it's important to know where we're going so that we keep moving in that direction. And the Saturday conversations are AJLC 2.0 priorities for design study, priority items to include in program statement for fundraising, and setting priorities and process moving forward. So everything that we do should be aimed to informing those conversations tomorrow. And I think these two primary assignments first to synthesize the products of the envisioning sessions and the condition assessment into the outlines of a program statement that will then guide 2.0. That being the first assignment. The second assignment being to provide the college administration and board with sufficient reason to authorize this capital expense and to develop a fundraising strategy. Obviously, one of those presupposes the other. Without having the support of the administration and the board, the most brilliant, detailed, compelling program in the world is irrelevant. So we have to keep that in mind too. We've got to figure out how to make the most compelling case for this. As we go through, don't worry about hurting my feelings or Kevin's feelings. There are ways of looking at where we are today. One of them is things we got wrong. And, you know, we did. We got some things wrong. I think a lot of people have said, we don't tell the story very well. in the building. Fair enough. That wasn't really our main goal as we scrambled for years to get this together. But now that we look at it, yeah,
Sure.
we could do a better job of that. One thing, we never anticipated this moment. We never anticipated people getting together and saying, okay, now we're at 25 years, where do we go from here?
Mhm.
So in our work today, let's anticipate this moment 25 years from now, 50 years from now, 100 years from now. Then there are things that have just simply worn out. And it's really interesting, as architects, we don't spend enough time going back to buildings that we did and seeing that, triple glazed windows have lost their seal, that the heat pumps are no longer functioning appropriately, etc. And then we have things that have improved significantly in 25 years. This is, in fact, great news. Control systems. Boy, the control systems here are primitive. I mean, this is Stone Age control systems.
Yeah.
And we now, and they were the best we could do 25 years ago, or at least we thought they were. EV efficiency has gone way up. There is the possibility of battery storage, things we got wrong. We thought the storage of the future would be fuel cells. It still may be, but 25 years later, we're still saying that, it may be, but we have batteries, blazing efficiency. Virtually nobody was talking about resiliency 25 years ago. Now here we are, it's huge. So, with that in mind, we are starting with the topic of ecology, landscape, and food.
We switched, we got to give you the new version. We switched a little bit because.
Why would I need to know?
Joe can only be with us this morning. And so we shifted more towards mechanicals and controls and that sort of thing.
As I was saying, we're starting with water. And that is Galloway and Norman. So I would turn it over to you all and ask you 5 minutes each as an introduction and then lead a conversation.
And I don't know that we're gonna need 10 minutes. We really sort of have more of a conversation around it and between Walt and I don't think we don't have individual field. So I don't know if you wanna start with your initial thoughts. And we sort of brainstormed like almost questions, bless you. And just for clarification, Russ, I see the discussion questions in the shared document. And even though I was part of the planning for it, Walt and I just sort of free flowed,
That's fine. Those discussion questions, you do not need to answer all those discussion questions. Those are prompts for looking back at the distillation document,
Okay.
trying to summarize what was said in there and you throwing your own 2 cents in.
Okay.
Yeah, so I think, I'll just start with, as I was flying in yesterday, I ended up with a window seat. And I was looking out the window and I saw what Chris thought was probably the Cuyahoga. I saw this meandering river. And first I ended up in geology, so that was cool. But also it sort of was a great representation of all of what we've been going through. This whole meandering process of what works, what doesn't work, what might we do next? And it was water, so I didn't know John was going to give me water, but it was a great intro for that. And I think for me, as I say, I've been here more as a observer and walking through the building. One of the things related to water that I know, and Lindsay, I don't know if you've experienced this because we did it, you weren't on the tour, but inside the door at the end of the hall are these 2 pipes you hold on to, which one's cool and one's hot. The water flowing through there having been tempered by the heat pumps, right?
One of them is the loop going into the ground loop and one of
One's
them is coming
coming
out.
out.
So you were literally feeling the heat being extracted or rejected to the wells.
Right, and so that is water flowing. And then an obvious one, of course, is the living machine. You talk about water and water use in this building and how water is basically just in a continuous loop. through the living machine and back in. And so those things are like amazing. First, the heat pumps and the living machine. So that was, those for me were great places to start in terms of water.
Yeah, and I, of course, I thought with the living machine as well, and the amount of water it's like 80 or 85% of water is being captured and recycled in the project, which is visionary, as we talked about yesterday. But it's also one of those things that's we saw the elevator pitch of the elevator pitch. It's like that's the one of the things that people very commonly will refer to. And did you see the living machine? But there's certain the landscaping, of course, also reflects the more of the natural landscaping, the typology that you'd find in this part of the world, part of Ohio in particular. But I know too that there's areas where it hasn't worked out so well. We've got a lot of ponding, we've got a lot of I don't want to say erosion, but areas where it's not as as effectively managed. And I think that the landscaping also has reflected a simplification over time. And so again, I would think that there's opportunity there to re-envision or rejuvenate some of that approach. But related to water, we talked about as far as the user, the occupant experience. I don't know about the humidity management, et cetera, but as far as in the restrooms, they're just manual faucets and things. So there are low flow fixtures that could be addressed there. Potable refill stations. We've recently got a whole thing to again reaffirm for campus about not having single-use plastic water bottles, and part of that's been providing refill stations all around the campus. Well, there's not a good refill station here, but just sort of some of those initial things that jumped out to us. Rainwater capture, it was another one that came up, thinking about how can the site be trapping and absorbing the rain that falls here. We know that flooding is, as far as climate and resilience, is another element to take into consideration. Pervious pavement, ways in which we can have fewer hard, and I wouldn't say literally pervious pavement doesn't work well in this part of the world. We get salt and stuff, but ways in which our hard or impervious surfaces can be further mitigated, I think would be something to circle back to.
And what the cisterns actually do or don't do, how they're filled, where they come, what the whole idea behind them was to begin with, et cetera.
The site has cisterns right now, it's walking right now.
Yeah, but they're not functioning or.
The cistern works great. It's the
cistern.
removal of water out of it that doesn't work.
And what its purpose is, et cetera, is not.
Right, like what do you do with the water?
Right.
What do you
If you
do?
could-
In theory, it should be used to refill the pond since it has no natural, not a substantial inflow
But that
during a
doesn't
dry
work.
season. No,
Right.
my understanding is the cistern overflows into the sewer, so provides that pulse mitigation.
Why does it not work?
The pump that's in it has never functioned.
Hey, guys, we're gonna be using
Oh,
these
sorry.
things.
Sorry.
Just saying.
So those are some of the initial things. I think we kind of turn it over to the group for discussion. If anybody has a question, we're turning our things on the side. Are we calling on people?
Yes.
Oh, okay,
John.
all right.
As I listen to you guys, I feel like, this is an area that intersects really strongly with the stories. How do we tell better stories about the building? And I'm feeling like in what you're saying, it's like crystallizing in my head, like 4 distinct related stories about water. One of them is about, continuous cycling of water, and maybe linked to that water energy nexus, relationships between water and energy. And so part of the place where I think that theme could be told, that story could be told, is with sort of the handholds on the geothermal system, where you can talk about how, water is a beautiful way of transporting heat and coolness. And in fact, we're doing that at a whole campus level now. That's how we're moving heat and cold around the campus, is through water. So that's a thing. Another dynamic that also fits with water energy nexus, which you guys didn't mention, but I think is a big piece of the theme, is the water sculpture out here, which runs on the solar panel outside, which to me is really a model of the water cycle in the sense that the water cycle, of course, is driven by sunlight, which evaporates water. It doesn't quite work that way here. This water cycle is driven by a pump that, you know, receives solar energy outside and drives the movement of water, you know, down through the landscape that is the waterfall in there. But I think that's a piece of that larger narrative about water and energy and the water cycle. Then obviously there's the living machine, dirty water to clean water, which takes place everywhere in the world, but is condensed enough here so that people understand it. I mean, most people don't understand. You flush your toilet, it probably goes into a river system, at least in northeastern United States. It flows down and then it's picked up by a drinking water treatment plant, pulled out. It's drinking water and then it goes back into the river system. People don't get that. It's all condensed here. People understand that. So that's another key theme. And then there's the issue of water harvesting from the larger water cycle. To me, sort of figuring out, to me, a lot of these issues have to do with figuring out the overall narrative and the sub-narratives and how that story can be better told, and what we need to do as people involved in design to alter the objects in ways that help tell that story. You know, the handholds downstairs, obviously they don't have signage on them. You know, for me, I think what they need is also a flow meter in front of them. And then you tell people the amount of energy extracted or rejected to a building is the temperature difference times the flow rate. That's how simple it is to understand energy flow, you know, and then people just have a whole new insight. Oh, okay, every building in this campus, it's got a flow, there's a temperature gradient, and flow times temperature gradient, that's how many BTUs it's sucking in or putting out, you know? It's just like very simple. You know, it's like the simplest way you could possibly explain to people what buildings are doing.
Okay, so I've been retired as a facilitator for 12 years. However, certain things kick in. One of them is time. And I already see Rumi, Russ, David, Lindsay, and Kevin have their cards turned
It's a
up.
minute.
I don't know about the order of the first three. I normally keep track. Oh, okay. So, we better keep
I think was Lindsay next?
I think so.
David was next and then me.
Okay, so and to Walt's point, we were just trying to keep it to a minute and a half. So, okay. Go ahead, David.
The issue, the hydrological cycle comes up here, looking at the next 25 years, we're gonna see massive rainfall. And we're about, if I remember the numbers correctly, about 50 feet above Plum Creek. And we'll see water up in here, given the 10, 12-inch rainfall. So the point is, I think we need to think through the next 25 years, we're gonna see massive water events. That's it.
Right, that tees up what I was gonna suggest here, which is, I think one of the best ways to engage people in a building like this academically is to engage the questions of what the larger community needs to be thinking about, because it means that your neighbors, whether they be in other departments or in the city or elsewhere, are going to look to find solutions to the problems they're facing here, because they're going to anticipate and should be able to expect that this building will have tried to solve that problem before anyone else. And so I was gonna ask this question: what is the community gonna face in terms of water systems as the climate changes more in the next couple decades, and think about how we face those? So if it's that, then you start thinking more about, yeah, flooding events. What does that feel like? What should we be getting ahead of now that helps to test that out? I think it's just one of the best ways to make sure that people are proverbially walking through these doors all the time, because there's going to be some interest in that dialogue of, okay, is this how we're going to do it? Or are we going to do it in a different way? So that is probably where my focus would be on the water system question, sort of what is the community most facing in terms of changes in how, I mean, yeah, whether it's need for water, lack of water resource, or maybe the opposite of that, it sounds like.
When you
here.
say community, you're thinking the broad community, yes?
I am, but I mean, I'm specifically thinking, you know, even if it's places in the country or in the world that have a similar ecology to this place, then that's who will want to learn from this. So like where I live in California, we're not going to learn from you. We have very different water problems in California, but you can be a model for places that have these same ecological traits, and people will want to come here and learn what you did to try to adapt for that, you know, for a heck of a lot more rain, whatever it might be.
Okay, Rumi or Russ, one of those two, and then the Kevins.
Thank you. So when I think about water in the context of AJLC, I'm thinking about water systems at three different scales. One is within the building. How is water cycling within the building, moisture and everything else that, all of you have mentioned. Then water systems of the site where the AJLC sits. And then how does it interact with the larger water system of the watershed? Right, so my comment is focusing on the second one, water system of the site. I think there are opportunities to do, as part of AJLC 2.0, a hydrological analysis of how water flows through this site. The water that falls on the site, the water that flows through the site, and how does AJLC's landscape exterior interact with that water system? And I'll give one example of a green building. It's a residential green building in Oberlin, where I used to take my students to. And the building, it has a basement. It's in Oberlin, and there is a saying that there are no dry basements in Oberlin. This building had a dry basement without the use of a sump pump. And that was the story that, it's in Oberlin, there are no dry basements in Oberlin. Here is a basement that doesn't require a sump pump because the landscaping was designed to take all the water, the gradient would flow it around the building and then channel it, away from the building into Plum Creek, right? So thinking about that kind of, doing a hydrological analysis of the site and thinking about opportunities to, positively interact with the water systems of the site. Two other quick comments is that also thinking about as part of that. So I think there are opportunities in hydrological analysis and landscape architecture around the building that would interact with the water system to have almost like demonstration examples of permeable pavements, rain gardens, and other types of things that, I talk about those in my energy class and also my urban design class. And it would be wonderful to have those examples on site where we could take our students and also other visitors could experience those examples. Local community folks could see those and learn from those, in the process. So.
Very good, Russ.
Couple of things really, really quick. One of the biggest challenges in the Living Building Challenge is becoming water self-sufficient, drinking your own rainwater. As Amory famously has said, it exists, therefore it is possible. We did this at the Chesapeake Bay Foundation. I think it's worth considering as a goal here. Secondly, the question of scale is, I think, really relevant when it comes to water. And one of the great examples here is the Living Machine, which is built at a scale that is too big for this building. The great news is it has the capacity to help with the waste flows of other buildings. Let's figure out a way to do that. I think that would be a great story. The third thing quickly is that permeable paving, we had some experience years ago building a huge parking lot at a Ford plant with permeable paving, and the results of that were kind of surprising to everybody. They would plow when it snowed, exposing the dark surface. What was left on the surface would melt because it was dark, and then it would drop down through the permeable paving. And then it did not ice. No salt, no sand, no sand to fill up the pores, which is a good thing, no salt. In the case of a truck plant, it meant that they didn't have to wash every truck before they sold it. Would save them, $100 and it adds up. Invariably, in the next 25 years, thinking of that next horizon, every piece of paving around this building will be replaced. Why not, as we go, let's make it permeable? That's a thought.
Okay. Kevin,
Thank you.
and then Kevin.
You know what, I'm on the next one, so I can save mine for.
Yeah, we
Okay.
probably should try to keep on time simply because
Well,
we do have an hour before we're on,
So Kevin.
Yeah, so my card started to tip over when Remy was talking, because he touched on the same thing that I was which really picked up on Walt's initial comment of flying over seeing the Cuyahoga and that sense of the local watershed. And, you know, I love that map of the United States. That's just the map of all the rivers. And you start looking at that and saying, okay, so this place flows to that place. And, you know, in terms of like the psychology of consciousness of what, if everybody knew, every school child up to, you know, anybody who came in the building had a sense of what this local watershed is and had that mental map. So that the drop of water that does finally make it out of the cistern and through the pond, it's, you know, where it's going to go would be spectacular. And along those lines, then I was thinking, because I think communication and interpretation is a big thing that we're going to be talking about. It struck me the sort of powers of 10 communication that could happen as just a concept for this. And if you all are familiar with that, it was actually designers, Charles and Ray Eames, that did some phenomenal videos of, you know, in the 60s, 50s, 60s of the powers of 10, looking at scales up to the universe and down to the atom, and how that communicates at so many different levels. Water is a wonderful one because it is all about flow, and so many things here will be flows of energy, flows of materials, flows of water. The last thought is, we're coming here on a visit. Leo Evans took me through one of the gorges or stream creeks that's sunken down, and it was one of the most amazing walks I've ever had. And what amazed me is I think of this place as the flat area. Then you go into this other world, and it's a spectacular world, but kind of like this building, it's hidden until you see it. And then it's like, wow, it exposes this incredible place. So making the watershed at the various scales visible would be a wonderful thing for anybody who came in this building to understand.
So I've got Joe, but Bill, did you want to say something or were you just? Oh, okay. Bill and then Joe.
Yeah, just.
Let Bill.
Oh, sorry, go ahead.
Wait,
Oh,
you're
You're
muted.
muted, Bill.
A lot of our work is biomimicry at an ecosystem scale. So, and I can talk about this more later, but one of the questions we ask is, so if the building wasn't here and the native ecosystem was intact on this site, what would the water balances look like? What would be the evapotranspiration? What would be the infiltration? What would be the runoff? And using that as a model for what should we be doing is not dissimilar from the idea that Bill McDonough expressed on the what's now the U2 building in San Bruno, and that was, you know, for birds flying over the site, can they distinguish that it's different from what it would have been naturally? So thinking about that from a water standpoint, you know, what are the metrics of an intact local ecosystem, and how close does the building come to modeling that? And so this is a larger context for us of moving past net zero. We're coming to the realization net zero is not enough anymore. We need to be doing regeneration. And so regeneration for us, one of the ways we measure it is, what would the ecosystem here be doing? Can my building model what that ecosystem is doing?
Joe.
Yeah, just real quick with community, my thinkings like parking is an issue on campus. It's straight up reality. Always need parking. Parking's $10,000 or $10,000 a spot for underground storage. You're talking $10 a cubic foot in a lot of ways. A lot of our storage is underground versus ponds. And so that could be a potential like force multiplier here, you know, as you got capacity there. Think about, you throw 20 spots over here. Part of this project is a multiplier to help that happen. So there's a potential source of revenue to keep things rolling. So I think all the water things you have going on are probably all still top of the art, state of the art right now. You just need to fix them, and what can we add to it? So.
Go back to where we were in the late 60s, you couldn't have a car.
Here.
Here.
Right, which is something that we have
We'd like to move there.
Yeah.
We'd like to move there. A little hard to attract perspectives.
Okay,
Are we ready to roll to next section?
ahead of schedule.
Yeah,
How can that be possible?
way to go, Chris.
Efficiency.
Way to go, Walt.
Yeah.
Thanks, guys. Next section is communication and controls, and that is Kevin and John.
Right, I'm gonna start on this and then I'll turn things over to Kevin. Kind of, we had to put some systems together. On the face of it, communications and controls might not directly, you might not directly see the connection, but we'll get to there being a pretty strong connection. I think one of the strongest themes that the students reiterated yesterday that came out of the envisioning sessions was this sense that the AJLC does not tell the really compelling story that it needs to tell about its history, how systems function right now, how we envision them functioning in the future, so that people really learn from the building to the extent that they can and should learn from the building. On the communication front, there's really three major approaches. So there's two other pedagogical sessions. So this is about education, but this is specifically about objects in the building that communicate. And there are really three real opportunities that we see with these. One, of course, is the building's well known for the data dashboard, metering display. A lot of technologies incorporated in this building are now evident in other buildings in terms of taking technical information about resource flows within buildings, translating those into a form that's easily accessible and engaging and motivating to a non-technical audience. I think we all recognize there's lots more room for doing more of that and better of that in this building. We are not doing as good a job as we can and should do with the data metering and display, the interactive dashboard, screen sensor. So lots of room for improvement on that. And fingers can happily point at me for that not being better realized, but there's lots of opportunities there. So that's one piece of it. Another piece of it is physical signage, which we've never really had within the landscape, but I think we also recognize that we need to really get signage up. You know, the issue of rain gardens, for instance, we have a rain garden, it's right over there, but no one knows that that's a rain garden there. I mean, there's a very nicely designed rain garden right there, and people don't think of it as a rain garden, but that's what it is, it's a rain garden. So that needs better signage so that people understand that that's what that is, that we are capturing water from the center, it's being funneled over there, it's going through that, and then before it overflows into the rainwater drainage system of the city. So lots of opportunity for signage. There's some intersection with this. This is something I've been talking about quite a bit with Chris about the idea of not overwhelming people with text on signs, but having an interface between there. So there's a little bit of an explanation, a QR code that then you can open up an app that gives you a lot deeper information on your phone, more storytelling on your phone or on digital signs. So there's an interface between those two. The third piece of this, I think, is the thing that most struck me as someone arriving at this center, which is that most of the interesting functional aspects of this building are hidden behind walls. And so for me, and I think for many of the people who contributed to our conversations, windowing mechanical systems, finding ways to expose things. We talked about the handheld things. Well, they're lacking physical signage, but putting big glass windows in, making the HVAC look pretty. This is particularly important right now on campus with the SIP project, because when it comes right down to it, the SIP is two things. It's a lot of pipes buried underground that no one's ever going to see. And it's some big ass equipment that's in a building that is restricted access and very few people are going to see. We need to make it so everyone can see stuff. This is the obvious building to do that. It has it's not the geothermal system for the campus, but it's a geothermal system. If you understand how this one works and we communicate this thing's running at a whole campus level, then I think this is the place to tell that story. I think it's easy to do with windowing, a lot of beautification of the HVAC equipment down there. It's an easy win for us. I think there's other things we can better window. I think the fact that everyone remembers the living machine when they come through here has everything to do with the fact that you see it. It's got beautiful plants in it. You know, we need to make the mechanical systems evident to people. And then the real interface with controls, and where I'll turn things over to Kevin to make some points, is trying to really integrate. When I got here, the Siemens system was so complicated, so difficult to understand. I met for a couple of days with the Siemens folks. They did not understand their control system at all, one whit. And I was like, well, how are you gonna control the building if you don't control it? But they did not understand it. My initial thought coming in was, well, I'll just extract data from the building control system and use that as part of what we educate with. We ended up building with National Renewable Energy Lab a completely separate metering system because we could not integrate with their system because it was impossible to understand, overly complex, and just a nightmare is the only word I can use for it. We can do better and we should do better. Kevin, you're on.
Okay, so there's a lot to talk about with controls. You're right, they're old, but that doesn't mean that they can't be our friend. The sensor data is critical across all the different control systems, and when you have to build out a completely separate monitoring system to watch this for some sort of sustainability, you're actually handicapping the control system because we should be investing in better sensor technology that's on the actual controls themselves. And then for planned obsolescence of those particular components, but kicking the can way down the road, how are we gonna continually retro commission this building over and over again from that point forward? And I think that that's part of why it's critical that everybody can see what type of equipment is running. Like if we put an acrylic wall down where all the water source heat pumps are right now, and you were constantly able to see, this is the equipment that's keeping this hot or cold. If we had BTU meters on things, so we knew that this is how much energy we're extracting or pushing back into the ground here. What does envelope in the building look like? Envelope is absolutely critical. What does our, are we in positive or are we in negative balance in the building? And what type of effect that has on, the efficiency overall. I think this building being such a stunning example of where things could go. And also, I do think it's really important that this is an incredibly high performance building by design. And how do we take high performance buildings and then bring them into this next set of energy efficiency, what we've learned since 2000. And, that part of what John and I had talked about is leveraging some of the manufacturers wanting to be involved in education. Why would we pay for all this stuff outright when there's a good chance that the sensor and HVAC manufacturers would donate that equipment to these buildings? So that everybody could see that. I think and we've had a lot of discussions, Chris and John and I, we've just had a lot of discussions about how you involve and get the students excited and passionate about what's happening in these buildings. We're at a major deficit of really good controls guys in the field. It's like a lost art, and it seems to go up and down on a cycle. If you went and you looked at control systems of the 80s, a lot of this stuff everybody cared about. How are we gonna transition systems from heating and cooling from morning to night? And how are we gonna efficiently, keep rooftop units and outdoor air units? There was a point at which there was a set of engineers for these buildings that really cared that filters got changed. That just doesn't happen nowadays. And so you put in, by design, you guys spend a lot of effort putting together water source VRF systems for buildings, super high efficiency refrigerant and super high efficiency use of refrigerant. And then nobody changes the filter on it. The thing's destroyed like 10 years later, but it cost you more money to go and put this thing in to begin with because you were tuning that towards energy efficiency. So this whole ecosystem of who's gonna maintain that equipment, why should you care about it? If it's hidden away in a closet, no one cares. That filter's gonna get changed on it. No one cares if the equipment isn't running. And when a sensor dies, they just handicap the equipment and make it just run full tilt all the time. So we lose all that planned efficiency that exists in there because it's hidden in obscurity. I mean, it's just, nobody thinks about it, nobody's caring about it. So I think that the more you can expose in a building like this, and you can make all that stuff really pretty too. I mean, I've seen, you've got some amazing plumbers that come in these buildings and what they build is artwork for, for water loops for everything. I totally agree. I mean, I think that we're probably gonna be able to get a lot of really good data out of the district geothermal, right? Everything we can ground couple and then maybe show, here's what the plant efficiency looks like versus what this building is dragging off of that plant or producing back to it. If we could get some of the manufacturers to put VRF equipment in here, chances are that could run off the solar array in the parking lot. And you almost could island this building. And if we could get to that point, you could show how these little individual ecosystems, can really exceed a net zero point. There's a lot of things that you can do with the water loop that's in here that doesn't require any compressors. we do in a lot of these buildings what's called water side economizing, where we just pass fresh air right past the ground loop without ever running compressors. So it's just using the ambient temperature of the ground loop to condition the building. We get a lot of dehumidification out of that. You can heat the thing in the winter. We might even be able to do it without fans if we can pass some ductwork underneath here and convectively move air through the facility. And you could do that in a living machine where that's filtering the air before it comes back in the building. There's so many examples of just little things that can be done. I've tried as hard as I possibly can to get the powers that be in downtown Cleveland to do this in some of these buildings, and we've gotten some things to go through. Terminal Tower, putting energy recovery on the elevator system. So every time an elevator goes down, we pound that into a battery pack and that uses it, the next elevator uses that to go up. So we offset a lot there. At Reserve Square, which is in a 1,000-unit apartment building, they kind of let us run wild a little bit there. I take inside that building is WRAA, which is a huge facility, which is the organization that manages aging or helps people manage aging. And then there's Channel 19. Both have huge energy use. And we're using all of the data centers that they have there. I take all the heat from that and I reject it into the tempering tanks for the domestic hot water for the apartments. It took the bill from $50,000 a month to $5,000 a month in gas. So there's all these things where thermodynamics moving energy back and forth. This is a whole generation of people that if they learn that, we can build buildings that way, and we can build them so that kicking the can down the road, they're ready for the next iteration of what comes in. And so I'm excited to walk down whatever paths we can here. I love coming out here and spending time every time I do with this whole team because this is the direction we need to be headed, and I'm really excited that there's a group of like-minded people that are also dedicated to making sure that becomes a reality.
I see a lot of cards up.
So I
I
see-
have no idea what
I do.
order. Is anyone
Okay, well,
tracking
I
order?
do.
Because I'm not. Okay, you are the order tracker. then, right?
Josette, Lindsay,
Okay.
me, Russ and Kevin.
Okay.
Kevin and Russ. All right.
All right, I have two big notes. For one, John, you were talking about window and mechanical systems. And I have been working alongside John and a student that was in my environmental communications class, Nev, on the there's a display case in the science center, and we're working on revitalizing that and redeveloping it to tell the SIP story better. And John had been talking to me about how the college isn't really making that connection that like the AJLC is home to the SIP. The SIP wouldn't exist if the AJLC didn't exist. And I think that just provides such a strong opportunity for that story to also be told here through those windowed mechanical systems. And I think that needs to happen here so that students can make that connection and so that that story just starts to be told. So that was one big thing. And then the other thing I was thinking, I think Kevin, you had asked how do we get students excited and involved in this process? And I think that is something that is critical to every single discussion that we're having. I don't remember who said it to me last night, but someone had mentioned that when you're asking the college for funding or you're trying to get something done, one of the first things they ask is how are students involved? What role are they playing? And I think if we, with anything that we're considering today and the discussions we're having, that needs to be something we consider, especially in terms of like having a good pitch and, making the most compelling case for the AJLC, that needs to be something that we consider. Yeah.
Lindsay.
Okay, so first of all, fun thing just to introduce, those windows are called truth windows. And I was just verifying that on Wikipedia, it is in fact the term, so where you cut a little opening in the wall and put glass so you can see the wall. I wanted to pick up on what Kevin was saying about the lack of about the shortage of really great engineers to do controls in the world and talk about this. I'll try to be really brief, but like one of the things I've seen time and time again is that buildings like this get designed with controls that are so complex that they start to fail immediately. And then essentially the building is not operated the way that it was meant to. And that there are big consequences to that in terms of what this means for actual global emissions of the building sector. It means that we keep saying like, oh, it's net zero. Oh, this one's net zero too. And then none of them are because the sensor falls out of repair and then suddenly the whole thing's out of whack. So one of my favorite thinkers on this, it's a group, they run a group in the UK called the Usable Building Stressed, and they talk about how if you have really sophisticated operators, you can have really sophisticated building controls. If you don't necessarily have sophisticated operators, you need to have simple building controls, basically, because sophisticated building controls with a basic level of operation, it isn't going to work. So I was thinking through, as Kevin was talking about, like, how do you make sure that you have sophisticated operators in this building all the time that can actually make sure that this building is tuned the way that it needs to? Or do you need to kind of recalibrate your expectations and move towards simpler controls? What I think would be cool is if you could count on sophisticated operators because there was an expectation in this building for the long term that it was going to be an educational space for people who were learning controls, which might mean community college relationships. It might mean relationships with other sort of technical, I don't know what you have around here, but basically ways for people to learn those kinds of systems such that you reliably knew there were going to be people coming in here and looking at that stuff and making sure it was operating. If you can't do that, you need a backup plan to make sure that these controls can operate simply. And it's not just because things fall out of control, it's also because you're trying to make the building usable for students and others to just come in and say like, oh, I wonder what this button does, because that's pedagogical, right? To sort of push a button and see what happens. But if they push the button and then it brings everything out of whack and, you know, it really doesn't do what it's meant to do. So figuring out that being really realistic and finding where you want to be on that spectrum of like high tech, you know, high touch.
Yeah.
Versus low touch. And I think controls are much better than they were. So maybe there's a way to do both, but
Yeah, I mean, the
yeah.
physical part of controls has remained the same for so long that a lot of times we can just come in and say, we're not changing any sensors and we're not going to change any of the equipment. We're going to change your control strategy.
Yeah.
And a lot of that can be done without human interaction when we're automating retro commissioning for these buildings. But it's important that everybody understands the concept of why we're doing retro commissioning and what's happening with this equipment and what is overly complicated versus what is simple. And creating, I think that one of the advantages you have to the exposure that this building gets globally really is that it can set a standard for that. And it doesn't, part of the reason I started building software is because controls are too complicated. And we just literally, we were like, well, what can we cut out of this to make it really easy for people? And we got to that point, and that's how we ended up talking with John to begin with. And we're going to continue doing that. And we actually kicked out an AI startup so that we can start building AI rule bases that can handle that, variance in, equipment efficiency, the health of the equipment, but also the health overall of the building. There's just a lot can be done here, and I think that engaging students in wanting to be involved in that and showing them how critical that is, and how overlooked that is.
Yeah.
And what that really costs you down the road in energy, what that really costs you down the road in, imagine having to demolish brand new equipment 5 years down the road when it should last 30 years. So it's important that everybody get excited about that because there's no way out of this without everybody getting engaged in the mechanical and control side of this as well.
I'm gonna do a time check for Russ now. We have lots of upright cards and I want to make sure people calibrate themselves to the half hour we got.
We're good. So, Kevin, Russ, me, Kevin, Russ, Ben, Joe, and David. I won't say mine's quick because that never works. But it is. High performance buildings, that term is a problem. I don't think many people, when you, in the lay public, when you say high performance building, they probably look at you cross-eyed. What do you mean? A high performance? We need a different term. I don't know whether it's sustainable or, it's something. But to me, I realize as we sit here talking, high performance, what, it's gonna walk around the town? Is it gonna play a lot of music when somebody, what's it gonna do? What kind of performance are you talking about? So anyway, that was my comment along the way. So, Kevin.
Okay, well, a couple things. One is Kevin was talking, just all of the discussions about truth windows or seeing equipment, trying to show function. You open that window and you're still not able to look inside the pipe or look inside the machine or look, so it's great that you see that, but I wonder, like from the design side now, starting a building with the capabilities of BIM modeling and all, you build the entire building before you build the building. So there exists a building in 3D.
Yeah.
And you put in, hopefully, every system that's going to go in the building, so you get the clash detection and all. And I'm just wondering if what should ride along with this building now is a super sophisticated BIM model that has every piece of equipment that you could, so that people both here on a dashboard could pick it up, see it come up, see it disaggregated, see it where it is in its useful life period. So this is the 20-year-old heat pump that, if we're lucky, it goes another 10 years. If not, it's on this decline. It's operating like this. Every piece of the building could be tagged in that way. Jumping farther afield from a cradle to cradle standpoint, or you could look at material flows. This is here, this is its net, this is energy implications and all. So I think that the model of the building, we have the physical artifact, but now there's also this other piece that could be part of it. Other thing, historical note, Johnson Controls, as I recall, showed up at the building after the mechanical system was installed, right at the end of construction. They were not at the table. They,
During
integrated design.
Siemens, I think, but
I mean,
yeah.
Siemens, sorry, yeah, Siemens, sorry. Yeah, so that's just part of the way things were done then and different now. And I think having somebody here, whether it's in a design build mode or just whatever it is, it's the boots on the ground, actually physically engaging this stuff that's critical. Last thought is around communication and signage and thinking about, Chris, about zoos. My daughter was part of the team that did the wayfinding signage for the Houston Zoo. And just what that took and what the sophistication, what they put together to communicate to a crowd and make it beautiful, make it informative. I just wonder again of how the ripple effects happen as the type of signage and communication happens here in the building, in the landscape, going out. It would make sense to me that it starts to intersect and start to work its way across the campus in little Easter eggs or little moments that make sense, and also across into the community in the same way. And whether it's self-similar to the existing campus signage or so different that you're aware that there's a difference, but just as the SIP program is now, the whole campus is plugged in. The whole campus eventually 20 years from now should have depictions of how things are working everywhere.
Yeah.
And so that's another thing that could grow in a ripple effect from here.
So before you move on from that important point, because the controls industry actually just by sheer happenstance has something that's sort of being developed that I feel like would be really awesome if it got fully implemented here. When you develop all those BIMs, have any of you ever used something called Magic Leap before? It's augmented reality. And so we use it in very complex central plants where the BIMs get uploaded into this Magic Leap device. It is 3D aware via the 22 cameras that are on the outside of it, where you are in that facility. But what we've implemented into that over the past two and a half years or so is live interval data into that. So when we go and we take a look at, let's say like a rooftop unit, it's compressors inside, all kinds of sensors, want to know what the filters look like, what the air temperature look like. I usually take these things and put them on, loads the whole BIM up right in front of me. So now I can see what all the refrigerant temperatures look like. But if you did that campus wide in there.
Yep.
And we have a relatively easy way of just aggregating data or pulling data out of the existing controls that are here. That's something that could be implemented baseline right now to show how inefficient things are. Or where that's drifted to, and then how that's coming along moving forward. That could be done anywhere.
You could probably run the tape backwards and show how it progressed,
Right.
how you're making
You could
progress.
even see this piece of equipment was removed and this is what was put in its place to make it more efficient, and that's what that looks like. And I feel like that zoo concept, because we actually started doing this at the Cincinnati Zoo, because they have a giant.
Oh,
sewage
yeah,
system there.
right.
So people pull me into these obscure projects all the time, and I love it. I love the people I've met. I love all the things that get it.
Mark
So,
Fisher. his-
To me, like, if you're walking around the campus with a set of goggles on, it is your world, it is your reality, but here's all the things you don't see normally that are occurring there. I think that would be fantastic.
Hey, Ben.
Oh, I'm up. Okay, fantastic. I just wanted to go back very quickly to what Lindsay was talking about in terms of the matching, the operator and control complexity. And adding another sort of layer onto that, thinking about some of the questions that we're to look at here in terms of what's gone well and what hasn't. In some cases, the controls may not necessarily have matched the equipment either. Or been sort of created to match the expectations of the occupant. I'm thinking of specifically things like, the building automation system is set to manage the windows during the warm months, so that we are open when we are supposed to be open and we close when we're supposed to be closed based on heat, humidity, etc. And that's a wonderful idea until the actuators stop functioning because the windows are too heavy, for instance. Now I've got 4 open windows and it's smoking hot outside and I'm trying to cool the place. I can't do it. And then they stay broken for a while until it starts to get cold. Now the inside's 50 degrees when it should be. So matching those. There's other similar instances of things like that around here. I know John will like to point out that open window when lit button / red light is hyper uninformative. Nobody knows whether that means you can open them or there is a window.
It worked, ever.
And so little elements like that, there are thermostats in all of the classrooms, but they're very logically not functioning. You can't change the temperature in an individual classroom, but there's no information for the occupant to be able to make any choice of any type. It's just frustration rather than facilitation. So, and then the other thing I wanted to just bring into that not meant into that, but it's an adjacent, concerns the idea of signage. We love signage. What we don't like is cohesive signage, right? We like information that we need to get to people right away. So let's put something up somewhere, wash your dishes, or that's the AC cabinet, how do we maintain sort of proper visual grammar, vetted and make it cohesive, but not make it take 8 years to get a sign that's going to match your needs. So there's some interesting pieces there. Sorry.
I've got Joe, David, Russ, and Cindy.
I just want to echo what Lindsay is saying, matching the sophistication of the controls with the sophistication of the workforce and the capabilities. Like we're between 2 controllers right now. We've had Siemens on campus. We've got Wadsworth, Schneider controls that we're starting to integrate. So, I mean, it's in the business, there's some big protective moats around all those companies.
Yeah.
So I mean, one of the things that what I would want to get out of this is obviously get this thing running where it should have been, where it was intended. There's some things that we want to integrate state-of-the-art opportunity to do that, but I'm so glad you mentioned that, Kevin, and what you mentioned is just to really spend a lot of effort and the lot of the resources on making this a sustainable, like controllable building in terms of that. It could be that testing ground or that lab where we start to bring in the next, herd of controls engineers potentially. But I mean, I think that could be a really powerful outcome that really speaks to the things that are eating our lunch right now.
They are, yeah.
So I mean, that's like, I'm always looking for these win-wins. Not having things in silos, and that would be a win-win that I don't think you may have thought of it, and it just kind of occurred to me as you were talking, so.
Can I just ask real quick, so are you basically still in that transition where Schneider wants to win more of your business? Because If so, that would be a good leverage
Leverage.
point to say,
Yeah.
we want to do something cool with you.
Oh, yeah, yeah.
So I started this.
Yeah.
When one
Yeah,
of these meetings, I actually brought in the Schneider. I have board seats at Schneider and Siemens. I do a lot of consulting for them. A lot of the products that are coming out now that are more and more open and doing a lot of I
Great.
spent 4,000 hours on a thermostat with Siemens that does a whole bunch of smart stuff for rooftop units. Because they handed it to us and we're like, this is garbage. This will never work correctly. So we kind of use that as leverage. We brought in Schneider. Schneider actually has an educational fund and may end up putting some grant money towards this and equipment. And also then continue to provide students with equipment so they can learn on it. And there's no reason why they shouldn't. We're deficient in people who can do this right now.
Yeah,
So
Cool.
that's,
Okay,
I think as a facility of higher learning, that these companies should be donating that stuff anyways.
Yeah.
It costs them nothing to do
Yeah.
that, so.
I think the only trick is to make sure they don't sort of lock themselves in. If
Yeah.
They say, we gave you
I'll
such a
make sure that
fancy
does-
thing.
Open
but-"
source. Make sure none of
Open
that.
source.
Yeah, that.
That's,
David,
Real quick question, Kevin, you raised an issue for me, when you do controls and you create savings, what happens to the savings? And one of the issues that we confronted 1.0 was when you save money, it disappeared into the general budget.
Mhm.
And so I think that once you start talking about savings, I think it's worth considering, how do you incentivize people to actually do the work that you're describing?
yeah, that's a great point.
And so, people ought to be rewarded.
Mm.
They're trying to get the reward system and the general budget. So Joe, that's really a question for you.
Yeah.
Is the system you're set up so when you have people doing a really good job on maintenance and they're changing the filters and doing that kind of thing, do they get, and you save, $10,000 in a month, how much of that goes back into the pocket of the people actually doing that kind of work?
We're not set up to do that, like, I mean, in terms of that level of just, translation from savings into somebody's
So
pocket.
it
I
hadn't
mean,
changed. in
that's,
25
but
years,
that
yeah.
brings up a good point, like, just in terms of how you manage all the different
Mhm.
assets here. And so, I mean, I could think from the employee standpoint, keeping that as like that ideal place.
Yeah.
But, we're looking at new ERP systems. And so, how do you look at, it's really about just, you get info, you get these facts, and are you able to pull any levers to make changes and control it? And that's kind of what
I
we're
think
working on, and so-
the point I'd like to make, and this is kind of a question, but the point I'd like to make is, how do you change more than just the controls, but the system that controls the
Right.
controls?
Right.
And then how do you make it worth somebody's time and attention and creativity to pay attention to those systems, exactly what Kevin's describing?
Yeah.
And I
Yes.
think my suggestion is this, is that one of the recommendations coming out, high performance buildings and low performance institutions don't work well. And so there's a mismatch. And so trying to think through. No, I'm not, this is not critical.
Yeah.
I'm saying, but for 25 years, we encountered this on the first 1.0. And I think there's some progress, but the suggestion very simply is, as we learn about controls, then what do administrators and people who manage budgets also need to learn? And the point being to incentivize people to do the right thing and the smart thing at a time. So anyway, that's.
I also think that if you took that angle and you were like, look, here, again, baselines are important. What does this building cost right
Mhm.
now to function? And what could putting more energy efficient equipment or just an ROI in general on whatever gets performed here, then get reinvested in the building? And a lot of people I've met, your controls engineers here, are very passionate about their job. And more likely concerned about the ability to do their job as best they
Right.
can and have the resources for it. And I think a lot of us would be excited if we were like, I learned a whole bunch about this controls and about the building, and here's what I want to do. And we've literally actually sat with your guys and they've been like, here's all the things I want to do. That's difficult without a budget to go and do that. Why can't the building generate its own budget to go and do that
Yeah.
via energy efficiency and
Yeah,
savings?
and the idea of the person who stays on the job for an extra 30 minutes after quitting time to make sure to get it right. Those people need to be appreciated and rewarded in some fashion. I'm just talking about calibrating these two systems, because it's not just building control.
Yeah.
It's the system that controls all that. What you call administration and so forth. I don't think anybody intends not to. I think it's just it falls through the cracks.
Yeah, I think making their job more enjoyable by allowing the building to generate its own
Yeah.
resources for the things that they become passionate about will just beget more passion for that job. And I mean, that's how you progress this forward. People have to really enjoy what they're doing too.
Russ?
The original commissioning process on this building was highly instructive, and that's when Ron Perkins came in
Yeah.
and saved our bacon. Because the building was, I mean, we did this state-of-the-art building that was performing like crap. And Ron came in and put in his own data loggers and went around and started to discover, you know, odd things that were cycling on and off all night. And nobody knew, because no one was here all night, and unnecessarily so. And really tuned it up quickly. So this is an exercise here in retro commissioning, if you will. But could we use this as the generation of continuous commissioning? I mean, how do we continuously commission a building, and who does it?
Yeah.
One of the things that we might consider, and you know, I'm out of my depth here, but you know, that's what architects do. What if all of the data that's being collected, I agree that having two separate data collection systems is a little stupid. Any data we collect should be informing the operation of the building, not just being used for academic papers. What if all of those data were in a form that were useful and it was crowdsourced? So somebody studying this, you know, in Arizona, could access the data and do a thesis paper on it, or somebody who is going to be is entering the field uses this to study, or someone who's trying to do a building like this has access to the data. Crowdsourcing exposes some unbelievable things, because people discover stuff that you're not seeing because they're spending more time looking at your data than you are. I don't know how to do that.
That is actually true for the autonomous data that we collect, not true for the building automation data, but that data has always been available to the world.
So the third point about also on the topic of rendering things visible, and someone could quickly chase this down. We have fire doors on the mechanical equipment room. I presume that is or was required by code. Because you don't put them where you don't have to put them. There is no combustion that goes on in that room.
Yeah, there's none.
It's all
I
electric.
think even the boiler's electric.
Yeah.
Isn't there? Yeah, there's nothing.
This is an entirely electric building.
Do we need to put something in there that burns?
What we need to do is to change the sign on the door, so it's no longer a mechanical
You
equipment
just
room.
put closet.
But yeah, it's an equipment storage closet.
Yeah.
And then I think we can put glass doors in. Now, obviously, someone's gonna have to really research that, but the reason for the fire door is for combustion.
Yeah.
For fire,
Right.
and we don't have any.
Yeah. The equipment's already gonna shut down and smoke's moving through the building, so it's not even gonna be running if there's a problem.
I have the cleanest and tidiest mechanical rooms I have ever seen are the ones that are visible to the public.
Yeah.
Funny thing.
Isn't there? So I would love to see us open that up and then start to, you know, signs that say what direction the
Right,
stuff is
exactly.
flowing,
Yeah.
and
That's
stand there and
pretty
study it.
Understandable.
One of the things that is really interesting about you talking about sharing this data, as much of this data we can, as well as the controls data, is what's happening in the controls world is us building a model that's called digital twins. Every time we run into a set of buildings that same style of equipment, same sort of building footprint, we twin those and we start putting the data together. And eventually you can get to the point where, let's say, a weather system is moving through Chicago. And we identify a whole bunch of the digital twins that exist here. We could start preheating or pre-cooling a building or doing all kinds of things before that weather system hits. And then really start to proactively affect whole regions of buildings. It's something that the electric companies want to use this to make money for themselves. And I feel like we could stick it right back to them and use it for energy efficiency instead. So that model works out really well. And it exists as an interest in the controls world now. So we could utilize that to our advantage moving forward.
Cindy, and then Lindsay.
So I wanna echo pieces of what David said. So it was in response to Ben, who was talking about something breaks, it takes a while to fix it, and just thinking about the dysfunction of the institution. And I don't think we should demonize Oberlin, because every institution is dysfunctional, and this is a human thing. And so as the psychologist in the room, I just want to sort of lift up that there are human realities that we're dealing with. And so I think we want to think really intentionally and creatively about many ways to deal with those human realities. I mean, part of it could be an incentive structure, part of it is a culture change, part of it could be open source data, part of it could be students who are working on this to learn. I mean, you know, we've had situations during the Eco Olympics where students were very carefully looking at the data and discovered things that nobody else knew about, right? So I think there's a multiple tools, and I don't think any one tool will do it, because the truth is that institutions don't hire enough people to do the job, because they're always trying to cut costs, and people are busy, and people have competing interests, and this is just reality. So I think we need to build multiple strategies and multiple social and institutional strategies into making sure that the data that we have and the equipment that we have is being used, because that is not an easy task.
Well, you were running our show here right now, it seems, in terms of calling on people. Who's next?
Dave, you
Lindsay.
can interject if you want,
Can
go
I
ahead.
interject one point? One of the early meetings we did here in the atrium, your feet are on Ray Anderson's interface carpet. We brought Ray in to talk to a group of college presidents in the atrium down here, and exactly on Cindy's point, that's a really good point. And to use this experience to begin to raise questions about best practices in administration. I mean, how do you reward good behavior and so forth? It's not an easy question. And so you're exactly right. I wonder if this could be one of the outgrowths of this, is to talk to administrators about best practices and begin to understand the administration. How do we calibrate the built environment with the way the earth works physically? All those things we were talking about.
But also with the way our institutions work,
Yeah,
right? I mean,
exactly.
so this building is not just embedded in a natural system, it's embedded in a social system.
That's right. And there's a tendency to compartmentalize or silo various things, which we complain about in the academic part, but not necessarily the administrative part. Anyway, that's a good point. Thanks, Cindy.
Ray Anderson was a big person in collaboration, organizational development, people skills. He went to conferences about that kind of stuff. Had nothing to do with carpet. He was a pretty amazing person. Lindsay.
Yeah, so I'm thinking about a couple of living buildings and how they deal with some of these problems. And I mean, I think Russ, you mentioned it earlier on the waterfront, but for folks that don't know, living buildings have to perform at 100% net positive, basically, or they have to actually be, well, it's really like 105%. That's basically what you have to do in order to be certified by us for an entire year. And what that does, at least as an exercise, is it forces you to fix the things like, I mean, well, it doesn't necessarily force you, because if comfort is sacrifice, then theoretically that's, we let that pass. But generally speaking, what it means is that you have to get the building systems to work, and you have to get the energy bill to zero. Like that's the requirement. I think this building could use some sort of performance imperative like that. That really says we are going to get to this goal. There's a few reasons why I think that's helpful. One is that it gives everybody the shared motivation to actually get all the systems tuned. It also has a financial impact. It should have a financial impact that can be replicable by other buildings that start to understand that they could pursue sort of similar things.
It has reputational impact.
Yeah,
It
yeah,
does.
yeah, and if there was some way to try to pursue that, even if you just said this is going to be an entire calendar year where we do, we're an academic calendar year where you get that actual performance goal hit for the entire year, I think it would be very helpful. I also wanted to say that, to David's point about incentives for operators. one of our living buildings is a leased building where the different floors have different tenants, and the tenants sign a lease when they move in that gives them essentially an energy budget. If they go over the budget, they have to pay the landlord for the extra energy that they consume. So I wonder if there's something that could be done at the campus scale over time where you all establish energy budgets and incentivize, and it may be more of a stick than a carrot, but you could just celebrate people when they hit those goals. Something along those lines would be, it's doable, it's legally a little tricky, but you're on one campus. I think you could probably learn so there are some innovations there. Because I think it gets really tricky, I will say, trying to ask a building operator to control all the energy consumption in a building, because the occupants have a lot of
Right.
they have a big impact on it. But when you there are ways, people are figuring this out, how to make sure that you kind of stay.
Eco-Olympics is a little microcosm of that.
Yeah.
Yeah.
Okay.
And buildings can join and can opt in, so but it's preconditioned on, do we have the meters in place to be able to effectively track? And that's exposing that we just have not had a consistent, some of it's city meters that have failed, but I like that idea. And I think it's something we would have done.
Yeah. Okay.
Roomy, we've got about 5 minutes.
Actually, we only have 5
Yeah.
minutes.
We've only got 5 minutes.
Yeah.
Roomy.
Quick comment. Now I was wondering, one of the pillars of resilience planning is to think about modularity. And so in terms of like building maintenance, given the reality that institutions are not always efficient, can we make, design things that are by design easier to access and maintain and service? So when we're designing it, just, pre-thinking about like, if something goes wrong here, how easy is it to access that? And I'll use a very simple, almost unrelated example is that, the clocks in AJLC, if they ever go out of sync, it takes like 2 weeks, 3 weeks to get
Well, they're
them
new clocks
back.
now,
Like,
so it's better.
yeah, but what I'm saying-
It used to be
so-
centrally managed.
Right, so this was the reality that, a clock is not giving you the right time in your classroom. You submit a work order, takes 2 to 3 weeks to fix. Maybe, if we had designed like digital clocks that you can like easily reconfigure. So this is just a simple example to illustrate that, thinking about what's wrong, how things will be serviced, and just making it more modular, more accessible, to bring in more efficiency in the system.
That's probably one of the best points of today, because if you can't reach the equipment and you can't work on things or it's difficult, you don't. And so then they just sit there and die. So that's a great point.
Yeah, agreed.
We're dealing with that immediately with things like the heat pumps in both of your offices. Being beholden to a third party for the work because they are unique and complex and relatively rare has put us at basically a 6-month timeline from break to fix. And it's wholly outrageous, but it's the reality. And it's through no fault of our own, but thinking forward about things that are, easily serviced, replaced, et cetera, by our own staff. They're highly qualified. There's no reason they shouldn't be able to do these things. Just taking ownership of that process, I think is an imperative.
Yeah, and very quickly, just to interject another idea there, this also applies to upgradability, meaning that if it's modular, if it's easily accessible, when you have a new technology that you don't know about 20 years later, whatever we can do by design to make it more easily upgradable, would, make the building forward thinking.
All right, I'm gonna insert myself here. We have a few minutes before Mark joins us. If anyone wants to stand up quickly, go to the bathroom, do it right now, because we have 5 minutes. That's it. That's it. Stretch,
That's it.
get yourself ready.
That's that break. I was telling you it wasn't in here.
I know it's not in here.
Yeah.
A lot of things to talk about, as we can see. As we can see.
Bill still with us?
It's with us. But Mark is gonna be with us momentarily. Great.
I was thinking, we were talking about the social marketing. That's what psychology. I knew you already knew that.
They were there, they
They
were
make-
basically like CBRE
Um,
employees or
what
something.
pretty much-
CBRE is amazing.
I have no idea.
It's awesome.
I saw those.
Oh, yeah, you'll do fine.
They're all
You're with Bill.
done since
It's,
then. They're
it's sort of
doing different
biophilic
things, but,
stuff. You can
bunch
wing
of-
it. Just
okay,
look
you
at,
know, like-
I mean, take 5 minutes to look at it, but I have 100% confidence. You're leading it the way that these have been led.
Yeah, just looking at the summary of the.
The idea was for you to scan the, I don't have it here, but the,
Yeah,
the
it's so
distillation
Yeah.
document, just look at those ideas real quickly. You can wing it doing that. So Bill's all about
And my
biophilic. That's
my
what
most
put you guys
famous
together.
example of that is, I'm standing down at Terminal Tower one day, it was the second flood we had on the project. And we didn't know this, but we were already transitioning into the third flood. And all 1,500 horsepower of the fire pumps down there fired up, and it was putting around 6,000 gallons a minute down the stairwells. But the security guards were so used to the fire system making enunciations that they're just like, whatever. For 46 minutes, that put 6,000 gallons of the water down there. And so that was 46 minutes, $39 million worth of damage to the building. It took out 11 historical elevators. It wiped out the avenues. I mean, it was one seat and one Victala fitting in the fire riser that S.A. Comunal did not X-ray. Out of all the rest of it, every other one X-rayed there.
Oh.
And so that just finished litigation from 3-4 years ago.
Yeah, yeah.
It's just like-
Did you have to testify?
I had to live at the building for 6 weeks. They gave us apartments there while we went and restored everything that was there. And then I spent another 2 weeks putting together the timeline with the insurance's forensic investigators, and I proved it was coming. Because they got down there, they paid the guys from Johnson Controls to wipe the fire database. And the first thing I did when I got there was go to the jockey pumps, the fire pumps, everything I've got controls on. And I put my fob in there and pulled.
Oh
all the
my
data
God,
out.
so you had the data that they'd wiped?
Yep, I was there within 2 hours of the incident. I
They
went and
must
pulled up.
hate
They
you.
were furious.
They must
The
hate
looks
you.
I got in that room were.
You're like enemy or like, you have a security detail or what?
No, well, it's one of those things where like. The insurance company.
Yeah.
All the insurance companies. What process and $23 per for 40 years out. So this is, there's a long thing, and it's one thing when it's just a little device, talking about it, and like saying about it, like, second, approaching to reality.
One hopes so, don't get your hopes up too high. This guy can tell you stories about the difference between, planning and reality.
Joe, I'm so happy that you're here.
Yeah, no, it's good to listen in, be part of the discussion. Yeah, got just over 2.75 million square feet on the building ones.
This is 13,000 of it.
Yeah. But it's good to spend a little time on one building and apply those sort of concepts. That's the whole, what all this is, the pilot, the learning on that,
Yeah.
taking lessons.
Yeah.
Trying to extrapolate those across the bigger, so. Yeah, no, it's a challenge, all the administrative things that happen, just with leading teams, getting them to get out of PM schedule. That's huge right there. Start with some very basic, easy stuff and then kind of build from there, so.
How would you, I mean, a broader question that maybe doesn't really have an answer. But how would you gauge the administration and the board's interest in this kind of cutting edge research, building as research? Is that something that's seen as having value?
Oh, yeah, no, I mean, be having a, this type of facility on campus provides a lot of catching, provides a lot of good, positive academic outcomes. It's kind of sustainable. So, but but putting all that into action, so it's like you care about what you fund. And so that's the way I look at it. And so it's a matter of balancing all of different other priorities. It's just I'm like a constant drumbeat of like, oh, sure. Let's get all the priorities on the table, and everything is important. Some things are more important than others. What's the return on investment? What's the criticality of not doing something because of life safety? So there's all these things that come into play.
There was a sense when we were first doing the project that was something akin to indifference.
No, I mean,
Today,
All right.
hopefully we've gone past that.
Hey, Mike, thank you for joining.
Manifested.
Is that Lindsay speaking? You're really tiny on my screen.
Yeah, sorry, it's one of those owl things.
Yeah.
We have funny lighting in here.
All right, tell you what, Mark, this is John. Can you hear me? This is John Peterson here.
Yeah.
I guess I'm the convener of this. Thank you so much for joining us. Thanks to Lindsay for bringing you in. Maybe while we're waiting for the rest of folks to show up, we could do a quick go around of those who are here to just introduce ourselves, just so you know who's in the room. You want to go ahead and start real quick. You got 2 seconds to introduce.
Walt Galloway, looking at the class of 1969, Oberlin College. An environmental scientist with EPA for many years, retired now.
Nicholas Coughlin, current Oberlin Environmental Studies 4th year, part of the student team working on getting wider input and engagement and planning for this process.
Lindsay Baker, you know me. Good to see you.
Russell Perry, I was part of the original design team with William McDonough and Partners.
Chewing. Ben Hobbs, I'm the facility manager and community outreach coordinator for the building and the program.
Cindy France, psychology professor, environmental psychologist, chair of the Committee on Environmental Sustainability here at the college.
John Peterson, current chair of the Environmental Studies program at Oberlin, here since this building was constructed. First building occupant, I would say. Yes.
Joe Komar, director of capital improvements here at the college.
Sammy Singleton, also 4th year ENVS student and part of the student team working.
Joseph Apple, 4th year ENVS major, part of the student team working on this project.
I'm Kevin Burke with Parabola Architecture, was the project architect for the project with William McDonough and Partners.
David, you want to introduce
David Orr?
Hey, David Orr, hanger on, retired emeritus, and faculty at Arizona State University.
So Mark, I'm not sure how much you've had a chance to chat with Lindsay at all about sort of what we're doing here. This is a charrette focused on thinking about the AJLC at year 2020, at year 25 in its history, and looking forward, thinking explicitly about what needs fixed in the building, but also how can we redevelop this site in a way that provides an example for the next 25 years. And we brought you in to help us think about energy capture, storage, and mechanical systems in the building, because Lindsay told us there was no better person to bring in than you.
Maybe I'll just introduce
you
Mark
go ahead.
for a second, and you can introduce yourself. Just Mark, so you know, we've been talking a little bit already this morning about living buildings, and for those who know them or who are just learning about them, I want to say that Mark is an engineer that who has worked tirelessly on many of them. And as we were just discussing before the break, one of the things that Mark has had the pleasure of doing is making sure the buildings operate the way that his team designed them to in fact operate. So I think you've had a lot of experience, more than probably any mechanical engineer I know, in making a building actually do the things that it said it was going to do. So we're looking forward to hearing your thoughts. I did give Mark kind of the agenda for the day, and So he's seen who all of us are, and a heads up that we would ask him to pontificate for 5 minutes. Within whatever context he thought would be useful, so. Should we let Mark take the mic?
Yeah.
All right.
All right. Well, yeah, good morning, everyone. Yeah, pretty exciting to be here. When Lindsay reached out, I told her how, I was when I started my career back in 2000, and was aware of this building, and so it's pretty fun to be invited here to help reimagine it for the next 25 years. Yeah, I guess, I spent a little bit of time just thinking about this yesterday, having started in 2000 when the AJLC was about when it was built. PAE was a little, regional engineering firm at the time, and Paul Schwer, who we were also trying to get here initially, who couldn't be here, was my mentor and had sort of introduced me to the AJLC. We worked together on a lot of buildings over the time to try and bring sustainable design in as much as we could. We couldn't ever, like in those early years, get to anything like the AJLC, but it was always kind of this guiding light out there of what is possible. Over the arc of my career, I ended up moving to New York City after going to grad school after a stint at PAE. And I moved out to out there, and I ended up working for Stephen Winter Associates, partially because I knew that they had worked on this building, and I wanted to learn from the people who had, done some of the energy work on that. So all that to say, I guess I don't think I need to tell this group how important this building was and is, but for myself, having never actually been there, unfortunately, everything that this building and this team accomplished actually had a pretty significant sort of gravitational effect on my career, I'd say. So just first off, thank you to the team, everyone that's here today, for what you guys did, because it actually was really influential for me. And so since then, yeah, like Lindsay said, I mean, I went on to, get to work on the Bullitt Center and the Rocky Mountain Institute's Innovation Center, the Candida Building, and then the PAE Living Building, all of which within the Living Building Challenge are kind of somewhat modeled on what the AJLC did before the Living Building Challenge was a thing. So yeah, so just really interesting. Let's see what else. Yeah, the PA Living Building has been around now for a couple of years, fully certified as a living building. Net zero energy, net zero water, treating all our own waste on site and all that. And I've been involved in a lot of the commissioning of it since then. It's been difficult getting some of our systems working, but we're there. I've toured probably thousands of people through the building. It's an office building that's, gathering the interest of thousands of people, which is pretty interesting to think about, again, like the ripples of, what happens when you do something extraordinary like this. So, and then I read through some of the problem statements and the list of, things that need to get updated, and it's really interesting and honestly maybe like a little disappointing also, just to think about that 25 years in, things can seem so old and need so much refreshing. I remember reading Bill McDonough's book, The Cradle to Cradle, back in the early 2000s, and thinking about life cycle analyses now that we're starting to do, and understanding that the turnover of a lot of these systems, mechanical systems, is actually a really huge part of a building's carbon footprint. Yeah, so that's interesting, and just thinking about now, what can we do, and how do we do things in a way that's really flexible? One of the things with the PA Living Building that we talked about our building as a 500-year building, and we tried to design a structure that was resilient and systems that were flexible so the building could last 500 years. And in Portland here, Portland being a city that was settled in 1850, or incorporated as a city in 1850. You know, it's 180 years old. There's, you know, there's no buildings that are even close to that. My family comes from Germany, and I spent a lot of time living over there and sort of going back and forth. But my grandparents had this family farm, and it was a building built by hand out of mass timber. Is about 350 years old now, and so it's just interesting to think about the perspective of, you know, technology and time, and you know, it's really possible to build a building for a long time. Yeah, I guess with that, I would just say, you know, it's like I would love to hear about how long was the building intended to last for? Like, you know, when it was started, was there a goal set out of, you know, what was the life expectancy of the building? And as we rethink about, you know, what needs to be renewed, how do we think about this in a way that, you know, that maybe can last longer than 25 years before needing a real refresh? I'll stop there with that maybe. And I would love to know if there was a discussion about timeline of the building.
Mike, there was, it occurred at the very beginning. We had 13 design charrettes with students, and about 250 students were involved in those initial sessions. And that was started in 1995, spilled into 1996. And there were concerns about that. And they're compared to building stock in Europe and older cities where buildings would last routinely, as you know, for hundreds of years and be still functional. So I think the building, it made the load-bearing structure here is both steel and masonry, which has long life expectancy. And then the other systems, which will upgrade, which you know a whole lot more about than I do, but there's a whole idea of kind of plugging things in as they get better.
Yeah.
The theory was, and this goes back to the very beginning before McDonough and partners were here, but influenced by a presentation Bill McDonough had made here, that things like glazing in the curtain walls here in the atrium are center glass 8, and the assumption was that they would get better over time, and we would swap that out. That idea worked pretty well for carpet, low value things, but not so much for high value things, expensive things. But that was part of the conversation. So thanks for raising that.
Yeah. Mark, I'm real curious to ask you questions about looking forward as far as energy goes here. So in the original design, I know David and team thought really heavily about on-site energy storage, and we've had some good discussions recently about that. The reality is at the time, the technology was absolutely not there for doing on-site energy storage. There's been several sort of rationales for doing storage that are discussed. I don't know if you had a chance to look at the distillation document, but you know, one is obviously peak shaving. You know, this building is a commercial building. It does pay a peak demand charge every month. I was stunned after the first couple of years looking at the bills, knowing that even though the building was a net exporter, it paid a bill every darn month because of the peak demand charges. And so that got me thinking a lot about, you know, peak shaving as an option. So that's one piece of it. Another piece of storage is obviously climate resilience. You know, we're going to have more intense storms. We're going to be dealing with that. You know, what capacity? We've been thinking about this building as, you know, at the concept of the building as a resilient center for the community as a whole. You know, that means having power here. You know, that's a different sizing issue probably than peak shaving. So that's another piece of the puzzle. One of the economists who's within our environmental studies program was saying, well, you might think about peak shaving, but what you might also be thinking about is when can you send power back onto the grid when to offset the most polluting power that's going onto the grid. So looking at the grid patterns and saying, you know, I think it tends to be that, you know, that peak demand tends to coincide with most polluting use as well, but it doesn't necessarily completely coincide. So there are all these sort of different sort of things we might optimize and think about energy storage here. Yeah, if we have storage, then you can potentially not have the solar panels go offline when the grid goes down. They can continue to feed into the this storage. So there's a lot of complexity around those issues. I just thought I'd throw that whole mess at you and see what you have to say.
And can you tell them specifically, Mark, a little bit of what you did at the PAE building? And just because I think that's particularly, tell us if you don't think we should do what you did at the PAE building, but yeah.
Yeah. Oh, I think something like what we did would be pretty interesting. So at the PAE Living Building, we have a 280 kilowatt hour lithium iron phosphate battery. It's a series of batteries in a room, and then a microgrid that can control the flow of energy. We have 135 kW of solar on the roof of our building. The microgrid then decides that energy, is it going to the loads in the building? Is it going to the batteries, or is it going back out to the grid? And we did it for a couple of reasons. One was we're energy geeks and we wanted to have a system like this to experience and play with. But from a reality standpoint, also we had a need because of where our building was sited and the way that we were in a network area of the grid, so we couldn't export as much as we wanted. And the microgrid gives you a great deal of control, and we export only 50 kW, which is as much as the utility lets us export, and the microgrid can kind of manage all of that. So to that demand profile and the load flexibility, it really lets us tune that. And from a resilience standpoint, if the grid goes down, the microgrid will pick that load back up in about 1 second or so, bring the building back online, and then we can run off of the battery. We can charge the battery with the solar while we're disconnected. So, our really rough calculations are that if we're careful with our energy use, there's about 100 days a year where we could operate our business for a full day just off of the battery with the solar, and have enough to sort of pick up and do it again the next day.
Wow.
It's pretty cool. And we're enrolling now with PGE, Portland General Electric, our utility. We're working to enroll in a demand response program that gives PGE then a digital connection to our microgrid. And if they need us to reduce our load, they can do that. And the pretty cool thing is so I want to say so there's a monetary benefit to us. I want to say it was on the order of $10,000 a year they were going to pay, which when you look at the size of the battery room, it's about the same as the lease rate. So it's like the battery room kind of pays for itself as a rented space, basically, in our building.
You can do that, Lindsay. You just need to mute yourself.
Yeah,
Share screen.
I had muted myself.
That's super cool, Mark. I'm very interested. This is the kind of thing that I really want us to be able to explore with our local utility. We have a municipally owned utility, not the most progressive, 100% green power, which is unique in Ohio, the only one with that. But begin to experiment with these ideas of, using our facility as part of their, peak shaving. So it's not just us peak shaving to save on bills, but them being able to use, like Enernox style, that really experimenting with that concept.
Yeah, I feel like, when we talk about decarbonization, a lot of the times, all of the focus is on electrification, and that's part of the story, but if everyone just electrifies without thinking about their demand profile, it really doesn't work on the utility side. And these demand response programs are interesting to me because the batteries, to be totally honest, in an individual building like the battery that we have, other than that it lets us deal with this net metering situation that's kind of unique to our building, is not of enough value to be, worth the investment on the individual building alone. The value at some level is more on the utility side because it helps the utility manage all of these loads that are new and buildings exporting to the grid and all these things it wasn't designed for. So for the utility to be able to start to pay for some of that and say, yeah, that's a benefit to us, we'll pay you for it, is just like, that's kind of the turn that we need to make these happen more often.
Well, so one of the real goals of our particular center is to be a resource for the larger community beyond just Oberlin College. And so I think this fits really well with that narrative, and also with demonstrating something that, you know, I know other communities are doing, but I really don't think is being done in Ohio, of, you know, sort of, you know, load profile managing. And, you know, obviously we'd be a drop in the bucket in terms of the load of the city, but just being able to demonstrate this concept, I think would have enormous educational and community value.
Yeah. Yeah, you know, it's funny. It's like there's the drop in the bucket. It's kind of what I was getting at earlier, you know, thinking about how the AJLC, without me having ever stepped foot in the building, like honestly had a like pretty significant impact on my career. I think like some of the decisions I made sort of happened because of this building, you know, or at least were guided a little bit gravitationally by this building. And so the things that we do on some of these structures get noticed, and, you know, people go on and do things because they learn from it. So there's a ripple that's much larger, I think, than the actual effect of one building.
I could just jump in, sorry.
No, I got you, Remy.
So first of all, super excited about this particular route, because I think, you know, Emery Robbins has been talking about it in Reinventing Fire, that the future of electricity would involve not just renewables, but storage, district energy, microgrids.
Yeah.
So these are all sort of part of that future vision. So some personally excited, and also I think tremendous pedagogical opportunities, because, you know, in my energy and society, you know, we talk about storage, but there's nothing to show. Like if I could take students to actually, you know, demonstrate how it works, maybe even design assignments out of that management of the grid would be super exciting and beneficial.
I just pulled up these pictures and can take them back down again in a second.
Tell us what they are,
But
Lindsay.
on the right, these are pictures I took. On the right is the microgrid in the PAE building. On the left is their composting system for the wastewater. So that's what the
blue bins.
Are you
blue
generating
bins,
energy?
yeah.
off the Blue bins?
Yep.
Say that again?
Is that generating energy off the blue bins?
No, I'm just showing it because I have some slides.
I was just curious if that was.
The energy system.
Those are the exact same unit we have in the basement next door.
Next door.
Just a single unit instead of them in series.
And that's just compost?
Here's Paul on the roof.
What are they?
You can actually
They're
see the
composting toilets.
cool way that they oriented the PV. It may seem a little counterintuitive if you're thinking about solar access, but it allowed them to pack more under the roof. And then you can see, this is the whole building here. So this is not an impractical building. It's not a super granola building. It's a real office building in a downtown area.
Yeah.
But I'll stop sharing these slides. I just wanted to.
Well, so Lindsay, that captures, the roof of that is what's capturing all the water that's used within the building?
Yeah. Yep. Yeah, a couple things I guess unique about this. So yeah, that's our water capture. And so there's a 70,000 gallon cistern and then a water treatment system. And we've been drinking the water for a year and a half now. So far, so good. Yeah, no, it's yeah, the water systems worked really well. The solar on the building, it's 133 kW. That's about half of what we needed for our office building. And so we made a donation to another building about 5 miles from our site, also in the PGE grid. It was an affordable housing building. We gave them a 215 kW array as part of the development of our project, and then wrote a contract basically that the renewable energy from that is associated with our building. We buy, so we buy some power from the grid, and we buy renewable energy from the grid. So there's net enough renewable energy to go around, but there was enough additional energy to power our building. And it was really a function of the utility restrictions that we had on site. We couldn't net meter enough to be able to do it. And then because we're in a historic district, to the point of our building, being a, very normal looking office building, the city's design commission did not want any solar overhangs or things like that, like we have at the Bullitt Center. So that was what drove a lot of that. One thing I will say about the microgrid, so it is up and it's working and it's commissioned. It took probably 18 months at least to get that commissioned and working. So that was, that was no small effort to do that. And, in working through that, one of the things I thought about was, it's like electric vehicles and, you go plug your electric car into the charger, those are engineered specifically and they're mass produced, and all of the charging and sort of the smarts can get really designed. Whereas the buildings, they get designed, but it's designed once and it's a bespoke system. And then, we pulled in a Schneider microgrid and we had Blue Planet batteries and we're putting pieces together, and the level of effort that can go into that design versus what can go into a vehicle that's mass produced is entirely different. And so it's because it's this bespoke system, just takes a lot of time to just to commission and to get working. So as you're thinking about it, I guess don't underestimate how long it will take to to commission and really tune the microgrid.
Okay, so I just want to say, I talked to Russ as the facilitator. I just jumped into this because in my life,
You go, man.
what we
Russ is
call,
good with that. You
I'm
do it
doing what
all.
we call keeping stack.
Hey.
As somebody
Well,
other
that's
than the
too long.
facilitator, okay? So, Kevin, Chris, Rumi, that Kevin.
Okay, so I guess just a few questions and just a couple of short statements. This demand response is something I've worked really heavily with a lot of different people. And I think one of the advantages we have in just advancement in general in what's going on with buildings and grid development is the ability to take a building like the AJLC, but then also look at a whole bunch of these other little buildings and then aggregate the demand response together. So PJM calls this virtual power plants. PJM owns all the high voltage transmission lines in the northern part of the United States from east to west coast. And they're who's gonna be cutting your check if you're participating in demand response. We might even be able to do a few test curtails on this building, and the 2 test curtails might actually pay for all the controls. So we can make money back from that as well, especially when this building is not being functional for classes and whatnot. If we can take that load profile way down and then, I'm assuming the solar's not grid tied here, is it?
Oh, yeah.
Is it? Okay.
Oh, yeah.
And do they actually allow you to go 100% back in if you can?
Oh, it goes 100% back in,
Yeah.
but like I say, the economics don't work out as well as you think they would because
Yeah.
they're charging us a peak demand charge.
Right,
So we're getting hammered on peak demand charge,
right.
even
So
though
also credit
even though we're net exporting, we're still being billed.
So I
So
think that plays the case for storage here, right? Because
Yes.
we offset your peaks of storage.
also for aggregation, because if you aggregate that peak, it's gonna mellow out.
Yeah. That's totally worth figuring into the whole, general play here, because aggregating an entire college campus worth of buildings into demand.
I don't know if they like that, but yes.
Yeah, they probably hate it, but that's, yeah. But I'm fine if the power company hates it, that's cool.
We like the power company. They're good buddies. We need them to, they got us all the green energy we have. They're not our enemies. They're our friends.
But it's, that's somewhat unique to hear though, right? Because you actually have a power
It's
company
unique.
that's alt energy, like if
Yeah.
we were to go downtown to Cleveland Public Power or First Energy, they'd be like, we hate you.
No, right, exactly.
So,
Chris,
That's
Chris.
actually, thank you. So that's actually why I wanted to speak up, because Joe and I have both been involved with. So Evergreen Energy is a major consultant here on campus, or a long-term partner. They now have a contract to operate our central heating plant, but they've been the designers, for our SIP. But then as we're looking at 10-year renewable energy strategy, for example, what might that look like? They've been helping kind of guide that process. So we've been talking with them about potential for an additional 8 megawatt solar array production north of campus. Our conversations with the city have been that, because I've asked about combining storage with that because we don't get the generation that we have, we're paid on a flat rate, we're charged on a flat rate, daytime, nighttime. So the peak charging you're talking about, I don't know how current your information is regarding that, but what we're hearing back from Evergreen into our conversation with OMLPS, there's no incentive for us to install storage. I think there would be other benefits as we're talking about for storage, but it's something we have to continue to kind of unpack here. Because when we've talked about the generation, Evergreen, and again, Joe, you've been in those conversations, the storage, option is something they continue to steer us away from.
I think there's a difference between building integrated solar and a massive commercial, because that one goes directly into the city.
Yeah.
It doesn't go through any buildings.
It's not behind the meter.
It's
No,
not
it's not behind the meter.
Yeah.
Virtually net meter.
Yeah, so I don't know what you've talked about. I'm just saying there may be some differences in a building integrated solar, which is coming into the building, into our electrical panel. You know what I'm saying?
Yeah.
This is a little, maybe different. I don't know, though.
I don't know.
Yeah.
How is the parking lot solar? Is it tied to the building or it's
Yes.
behind the building's meter?
It is behind the buildings.
Okay. Was that part of the original design or is that additional?
Additional.
It was added in 2006. The rooftop array was initial, then the parking lot array, because we couldn't meet the 100%, production. We didn't meet the balance without that.
Got it. What's your balance now? Are you about 150% or so, maybe?
On our best years, 150%. I'd say the average is high 130s.
It's old technology, so we've had a lot of problems replacing inverters, not to get into it, but it was not running for the last year and a half. It's just running again now, the parking lot array. It's very old technology that's very hard to get anyone to work on.
Which is part of the innovation. Again, Evergreen Energy now is managing all of the renewable assets on campus on behalf of the school.
Okay.
Yeah, so the other thing in the mix is to consider V2G options, like vehicle to grid options. And I think if we have a microgrid, because those are like, to be like sort of forward thinking.
You're talking about like bi-directional power?
Right.
That's
So,
genius, because there's a set of chargers down the road.
right, so when we,
I'm not
if
sure
we
if they
have,
can
the-
do it,
I
though.
think
The
it
bolts
ties
can't
into the
do it.
microgrid and storage, mix,
Bolts don't
like
do it.
management of it, and that would be another sort of demonstration of, many different technologies on site.
Would be cool, Rumi, but that charging is in bolts. Bolts don't have that technology. It's only some electric vehicles that can
Yeah,
do
but
back and
if
forth.
if you are thinking forward thinking, 2 years later, 3 years later, electric cars may have.
Yeah,
those
yeah, I'm
technologies.
just saying.
You can also,
Already, I think like Ford Lightning probably has bi-directional,
yeah.
so there are models out there. So I'm saying, by the time the renovations are complete, we'll have more cars, and again, it will be another technology that we could demonstrate and people could.
Yeah.
That's one of those forward
Do you have
thinking,
any
we know that almost
buses in
everything
your
will be
fleet?
compatible with bi-directional
We
power.
just-
Chevy makes
Not
all
electric
that
buses,
energy
the city
for
does.
cars now to do it. But it'd
We
be
have
nice that
vans.
whoever comes
Utility
here can opt in more.
City has electric
For
buses.
Like by design to have it part of the design.
Maybe a small
Okay.
city in case of some sort of.
Let's get back to one conversation.
John, you still have something, John?
Oh, I'll pass. What the heck? This is so good.
Kevin?
Yeah, I'm curious, and thanks, Mark. This is such great input, and was really glad that you're going to be part of the conversation. And one of the things that we need to do, and Russ pointed this out at the beginning of our discussion today, is think about what we're doing tomorrow and the type of roadmap that we're trying to create towards ultimately getting to something, a compelling statement to the board for approval for the project to go forward. Two things that have been discussed is a sort of programming upgrade, but some type of, to me, a little bit mysterious design study. And that could be, I'd be curious just from your perspective, from an engineer's and integrated engineering perspective for a building like this, mean, there hasn't really happened that often to have this kind of 25-year upgrade. But how would you engage from a process standpoint in an early kind of opportunity assessment and design potentials? Or, you know, how can you do something that's quick but is in alignment with all that we're hearing on the control side, all that we're hearing on the building envelope wanting to be upgraded, natural ventilation incorporated, a systems approach to a very quick design study? Any thoughts about how that might happen and how that comes
If you
about
were to do
successfully?
it, how would you do it?
Yeah.
Yeah. I would start with, looking at the utility data and any, metering data that you have right now and try to understand what's going on in the building, what has been going on over the last few years, and look at that. There's that problem list, I think, is something that needs to kind of be gone through and understand how are some of those things impacting the building. Yeah, it's interesting, I had asked about plugging things in and like what was the thought for the refresh cycle. So I think, we would need to brainstorm a little bit about like, how do you use what's there so that all of the, investment and resources and the thought that had gone into the building initially, what's the next step with that to move away from R22 refrigerants to, R32, or there's a whole refrigerant transition happening right now that's causing a lot of difficulties for consulting engineers that are trying to spec equipment that doesn't exist yet sometimes. But, looking ahead to what's the next step on some of those systems. And to me, leaning into what's there right now, I mean, you have a condenser water system through the building that, like, honestly, moving water through a building is a pretty good way to go. That's a fairly simple thing. And yeah, I guess thinking about it, how little can we change about the building? What needs to get updated? What can we learn from based on looking at how it's operating right now? Without having to change more than we need to, because there's just an investment already in what's there. So yeah,
sorry, just quickly picking up on that, and that absolutely makes sense. Is there running alongside of that a type of what if that says, but for 25 years, maybe we need to think of something different? Or does it feel like there's enough this is a broad question, here in place that could ride out that next time frame?
I don't know yet. I guess I think we'd have to take some more time to look at the building and see. I think there is a flexibility question. I mean, incorporating a microgrid into an existing electrical infrastructure is not trivial. So, there's a question of how much flexibility is in what you have now. I feel like the electrical piece in this demand response is a really big move of what could be changed in the building right now that could make it work a lot better, both, from an operating cost standpoint and also just from a carbon and sort of mission of the building standpoint. So there's a question of flexibility on that. The mechanical being anchored in the geothermal system, understanding how well is the geothermal working right now. There's an electric boiler. That one sort of caught my eye. I'm curious how often that runs, and are there other things that we could plug in there that make that more
Never. It's actually locked out.
Never.
It's been locked out for a
Never.
while.
Love it.
So it won't run.
It will not run.
Unplugged.
There's a electric boiler that we just locked out.
It's
If
if
the
the geothermal
ground source
fails.
gets too
Yeah.
cold.
Yeah.
It was used in earlier years, but it's never used now.
Is it, how is it, why is it not used now, but it was used prior?
Because it's broken.
Okay.
No,
It was locked out without my knowledge, actually, so I
no,
don't know,
it's
maybe.
that we did improve the sort of management of the building. It was just very poorly, control system was poorly set up. And it was
Got it.
doing stupid things that required heat.
So the answer is Siemens.
Yeah. Well, that's great. I mean, that's potentially a big energy user. But yeah, I think, you can kind of tell from just looking at the utility profile sometimes, where the energy is likely being used, and without putting a whole model together, of what can you do? That would be kind of the next step beyond the,
Well,
just
the
looking at the
building is-
data.
The building's very well sub-metered. We divide out plug load,
great.
light load, HVAC. So the building is metered out the wazoo. So you'd have lots of data to work with.
Yeah. Yeah, I mean, that's the best way then. You start with that data, look at it. You can do a little bit of modeling of sort of key pieces, or maybe just some calculations to figure out what are the big moves, what are the loads you have. And yeah, I mean, other than on the electrical side, there's that whole piece. And then mechanically, I think all of the heat pumps that are distributed throughout probably need to be refreshed with new equipment. But you've got the geothermal that presumably is still working great. And you're really set up well for low, heating and cooling energy use. The dedicated outside air system, I'm not sure how well that's working now. The efficiencies, the effectiveness of the heat recovery is lower than what a lot of systems are now. But if it's working well enough, there's probably not that much of a payback of tearing that out and putting something new in, either from a cost or a carbon standpoint. But all of those would be things we'd need to kind of just run the numbers and kind of understand, how's it working.
Process-wise, just one follow-on then, for you or your firm to engage effectively in that type of process, an early design study, is there a charrette session or a couple of charrette sessions? Obviously, coming visit, seeing the building finally, and actually experiencing it, engaging with the team to follow on to this. But is there an optimized process for you to get towards that kind of understanding, and then be able to give valuable input towards these broader mission statements? Or
Yeah, I think, there's definitely some discussion with, visiting the building, talking to everyone that's operating the building and understanding what's going on and what the needs are, talking to all the stakeholders of the building to understand what are the important factors of, what are the needs that the building needs for the next 25 years. And then we would probably go back and, do some heads down work and some internal brainstorming, and then come back with ideas of, hey, here's some opportunities of things that we could see, and then work together to say, what's likely the right direction to go into. And then maybe from there, then like the next step is, to start to sort of do some modeling and understand, really what some of those improvements would do and would look like. Ideally to get you to, maybe 200% net positive with the arrays that you have.
Great.
Okay, we need to keep moving, Russ.
Couple of questions, not particularly easy questions, but let me lob them out there. One has to do with the PVs. When we were designing the building, a 25-year-old PV system had been put in 1970. I said there weren't a whole lot of them, and I remember thinking at the time, or being told at the time, that we should count on about a 25-year life for the PVs. The good news is they're still cranking away after 25 years. That's fabulous. But the question would be, moving forward, what do you do with 25-year-old PV system that is now a fraction of the efficiency that we could get today? Do you replace them? Do you move them somewhere else? Do you say, hey, they're still working, let's just tough it out and keep going and see how far they go? That was question one. Question two is, this was the first all-electric building that I ever worked on. And the premise was ground source heat pump, having the currency of energy being that fluid that's running through the building, and decentralized heat pumps, 27 of
27
them throughout the building. If we were doing it today, is that what we would do? And then decoupling and having ventilation independent from heating and cooling. Is that still a valid strategy? Specifically the 27 heat pumps, which means 27 separate supply, maintenance tickets, and all the other stuff. So I give you both of those questions to talk about.
Okay. Let me start with the heat pumps because I'm a mechanical engineer, and so that's the sweet spot for me. I have not in the last 15 or 20 years designed a system with condenser water and individual separated heat pumps throughout an entire building like that. So that not a common system anymore in at least in my experience. Because of noise considerations and maintenance considerations, cost also usually the system ends up being a cost premium over today, honestly, when you start to get into systems like that, VRF, usually owners tend toward, which we are not a fan of, and is turning out to be a bad idea both environmentally and also from a maintenance standpoint. But we've seen a lot of systems like that where you want this distributed. What I think, moving away from VRF, the moving water through the building makes a lot of sense to me and is a really good way to go. We've seen more, when you have distributed more like 2-pipe or 4-pipe moving hot and chilled water to individual rooms. And then with, either chilled beams, we've seen a lot of little radiators. The Yaga and Campman are two manufacturers that make radiators that have a fan, force fan in it. They can be trench mounted or things like that. Is a really good way to get the heating and cooling in rooms specifically, eliminate reheat, which is the nice thing that happens with the heat pumps that you have. So yeah, probably not the system that I would expect. And I was thinking about that as I was looking at the drawings of like, it's interesting. How do you replace this? You're kind of tied to these heat pumps in a way because the pipes are sized for a condenser water system. We could look at, could you switch that over to a changeover type system where then seasonally you're either heating or cooling? My understanding is there's automated windows that open and close automatically, but maybe the actuators are not working great.
That's in the atrium space. So that's the main lobby space as opposed to all there's obviously some big central heat pumps, but then there's a heat pump in every office and every room. And operable windows in the classrooms and office spaces. So there's the big atrium space, which is its own thing. It has a radiant floor heating system, and it's got the big convective, design convective cycle with the south side with the low operable, the low mechanized opening windows, and then on the north top. It works beautifully when it's working. I mean, done right, you can cool the building down at night, shut them, keep it cool for most of the day. It's a good concept, but it's for that particular space as opposed to the other spaces.
What I was thinking of with it was, so our strategy at the PA Living Building was we have a 2-pipe system, so it's changeover. It's either in heating or cooling, and we have radiant floors throughout. We're open office, and the radiant floor works wonderfully for us for that. And in order to make the changeover work and still maintain comfort, we have operable windows that are automatic, and we design the loads to be low enough so that in the shoulder season, there's kind of a gap where the windows can handle the cooling load if we need it. So we're biased a little bit more towards heating in our floor, and the floor kind of maintains it warm enough so that in the spring and the fall, when maybe you need to warm up in the morning, and then we can shut the floor off at the floor valves, and then the windows open, and that can deal with the load while our system is really in a heating mode. And then the summer we change over. So one of the things that occurred to me with a 2-pipe condenser water system you have is, could you convert that over to a 2-pipe heating and cooling system that changes over? And then can we look at the loads in the space, and can we still maintain thermal comfort through a combination of natural ventilation and then a changeover if we wanted to get away from the heat pumps? And then what you would do would be have a centralized water to water off of the ground source system.
And we do kind of have that for the radiant floor. I mean, it doesn't do switch over, but we have that water heat pump for the radiant floor system. That's the only one though for the radiant floor system.
Okay, yeah.
Oh.
Hi, Amory. Yeah, and then to your question about the PV, my gut, and this is as a mechanical engineer speaking, is that at 25 years, you were probably better off now replacing the panels, I would think, with, modern panels that meet sort of the maximum level of efficiency, and then either recycling or seeing what the way to, best reuse those panels if there's still a useful life for them. But that would be my gut. And then, at the same time, looking at what flexibility needs to, and what changes might need to get built into the electrical system to allow for the microgrid and the battery energy storage. One of the things we haven't talked about is where to site the battery energy storage. It takes some room. Putting it outside of the building is probably the best way to do it. Just from a fire protection standpoint, it tends to be better to put those outside. So if there's, maybe in the parking lot, take a parking spot and put the batteries there. And maybe it's a nice way to display it also. And you could figure out how to have that be an interactive and sort of pedagogical benefit.
Yeah.
Okay, so Lindsay, you're up, you're
Okay.
last.
I wanted to
Amory's
just,
here, so.
I wanted to just underscore something that Mark's been talking about a little bit in tacitly in his comments, that has become a significant factor in designing systems for good buildings today that was not a factor 25 years ago, and that is embodied carbon. And specifically point out that what we didn't realize 25 years ago is that the embodied carbon of the heating and cooling equipment is extremely significant in the overall carbon footprint of a building. Even though it may feel like it's probably little, because it's kind of little as it relates to the space of the entire building, it can be quite large. And especially in this case for an existing building, when we think about the work we want to do to the building, we want to try to think about ways to be creative, to use the things that we already have, not just for financial reasons, but to not essentially incur a huge new debt of carbon that we have emitted in this renovation. And so anything we can do, I mean, I think the idea of this, there's some real elegance to the changeover system you're talking about, Mark, because that's not going to incur, we're not going to be buying a whole lot more stuff. We're not going to be taking on a bunch of new refrigerants, et cetera, in that kind of a, but one of the nice things about Mark's firm and lots of these kinds of firms that are doing living buildings today and are at that cutting edge is that they do that assessment of the carbon footprint of these of the actual stuff you're buying. They can do that as a part of their work, and I'm sure, Mark, if we asked you guys take a look in that early analysis to understand what would essentially the carbon footprint of the stuff we were buying, what would that be?
And the stuff we're getting rid of.
That's right.
Yeah, what the stuff we're
Right.
getting rid of. Luckily, we waited 25 years. There are great solar panel recycling companies now that make sure that all of those materials do go back into new solar, installations and things. So it's but you could use them somewhere else on campus, but you could also send them to Texas and they'll make them into new solar panels and make sure those heavy metals don't go anywhere bad.
It's a very high capture. It's like 90% or something. It's significant.
Oh,
Yeah, some of the initial studies that we've done, Lindsay, to your point, on life cycle carbon over the life of a building, the MEP systems, we were seeing 35-40% maybe of the embodied carbon, just because it's getting turned over. And thinking about this particular building at 25 years, and especially this building that at 25 years we're talking about replacing all of them again, is just really eye-opening that it's real. These things have a relatively short lifespan compared to the rest of the building.
Yeah.
That we should conclude this section and move on and hear from Amory.
Yeah, Mark, thank you so much.
Yeah.
We really
Thank you.
deeply appreciate your taking time out of what's
Great.
important
Yeah, thank you. Thank you for the invitation. It was great to be here.
And I'm sure you'll be hearing back from
Yeah.
us probably through Lindsay pretty quickly.
Yeah, yeah.
Yeah,
We'll be in
but so
touch.
thanks so much.
Great.
That
And
sounds
you're
good.
You're welcome to stay on.
Yeah,
the
you're
line
welcome
as
to
long
stay.
as-
I'll hang on for a few minutes. I got an appointment I need to run to,
Leave whenever you
unfortunately.
need to leave. You leave whenever you need. You won't be insulted.
Okay, sounds good.
Amory Lovins, welcome to our group here. David, do you want to do a little intro here?
Oh, Amber, you're the only person here who doesn't need an introduction, but I'll give it to you. It'd be 30 minutes worth. I've known Amory since 1974. And Bill shortly thereafter. And Amory is I think the leading exponent, starting with a masterful essay, still the most reprinted essay in foreign affairs history, called The Road Less Traveled, The Road Not Traveled. The guy that invented soft energy paths and all that followed thereon. So Amory set out a life path that he's followed absolutely brilliantly and diligently for lots of years. And my shelf of Amory Lovins articles and books is about as long as this table. So quit it, Amory. And things that Amory called back in 1991 and asked for some timber out of a sawmill that I was part owner of. And so we cut the timbers that hold up his roof. And still there. Amory, great to have you on. Thank you. I remember that. I remember those.
Each one of
Anyway,
them.
Amory, thanks for taking time out of a busy schedule and appreciate your time and input and your inspiration for this project. Both you and Bill have been instrumental in lots of different ways here. So welcome, Amory.
Well, thank you. Let me see if I can make this thing work. Let's see, share this and play that. Do you see just a title slide without my notes?
Correct.
Yep, you're good.
Yep.
Good. Well, that's what's supposed to happen for a change. Your Adam Joseph Lewis Center reflects really outstanding vision and effort. It does great credit to all of you who had the vision, came together to create and sustain it. And that was an important step in showing how to make energy do our work without working our undoing. As that flagship building turns 25, you've kindly asked me to help you think about what could and should come next. And I'm going to focus on energy, but I expect a similar story could emerge if we dug into materials, water, waste, landscape, all the aspects of the original integrated design. And I suspect the way you have enlarged its lessons to dorms and other buildings on or near campus and built the campus resource monitoring system and used the center as a vital element of your pedagogy could also help similarly to scale the continuing innovation process that I'll suggest. Now, when I look on your website, I see the original intent was to create a building landscape system that would keep evolving and improving over time. No time limit was set. Innovation doesn't stop. And the need to create abundance by design in a spirit of applied hope is now more urgent than ever. So where can we go? Well, let me share with you a little experience here, because I faced the same question in my own home and office where we incubated RMI for its first 18 years. It's a 4,000 square foot building, actually all round feet, 7,100 feet above sea level near Aspen, where temperatures used to dip as low as minus 47 F. That was before global weirding, and our recent lows are pretty balmy around minus 18 F. You'll recall that adding thicker insulation adds proportionate cost, but it leaves less heat loss to be saved by adding even more insulation. So the cost per unit of saved heat goes up geometrically with thicker insulation. Normally, engineers add insulation only until its extra cost equals the present value of the saved heating fuel, then they stop. But this logic, which is in all the engineering textbooks, omits the avoidable capital cost of the heating equipment. So I just kept adding insulation until that equipment wasn't needed. And that made the construction cost fall back to slightly below normal. That's because subtracting the heating system saved more construction cost than I added for the super insulation, ventilation, heat recovery, and super windows that eliminated the heating system. So we then saved about 90% of the electricity, 99% of the water heating energy, half the water. And all of that together repaid the extra cost in 10 months, not counting bonuses like the lovely central atrium seen here in a February snowstorm. And so far it's 83 passive solar banana crops. Someone said I had really big earphones. Now, without having to look like this, our house helped inspire hundreds of thousands of European passive buildings that likewise have no heating and roughly normal construction costs. And of course, integrative design gives many benefits from each expenditure. So the central arch, that you see at the top of the upper middle image, has 12 different functions, but only one cost. And indeed, those 50 tons of oak beams and purlins were graciously logged, milled, dried, and shipped from Meadow Creek in Arkansas by David Orr and his brother Will. We are forever in their debt. Now, by around 2005, that building had accumulated a lot of deferred maintenance, unfinished aesthetic details, and other room for improvement. So my wife, Judy, who's a fine art landscape photographer, and I began pecking away at a renovation. And soon Judy realized that our effort lacked a clear purpose and vision. So she asked a powerfully simple question. Is our intent to maintain a museum of 1983 state-of-the-art, or to make this a living lab of the best new opportunities? Of course, once you ask the right design question, the answer becomes self-evident. So we started touching nearly everything in the building. That it went on for, well, 7 years or so, but it's still going on. We renewed the technical systems. Along the way, we made the building a lot more beautiful and functional. And that effort's continuing now, 20 years later. Every year we undertake several new projects. There's no end in sight. Innovation's perpetual. And Rob Knapp has now published a lovely book called Bananas in Snow Country about this building, including a foreword by Lord Foster, maybe the world's greatest practicing architect. He calls it an extraordinarily important building in the history of architecture because of its mix of technical and technical humanistic integration. And Lord Foster wisely urged us never to sell the building, but to put it in trust so designers could always come visit and see what we did. We're trying to figure that out. Judy also asked another wise question. Why are we still burning stuff? Because we were then getting the last 1% or so of our space heat from 2 wood stoves, and the last 1% of our water heating and all of our stove and oven cooking from propane. Well, it's nice to have a way to benefit from the abundant and ever-expanding supply of obsolete energy studies. And it was also a bit inconvenient to deal with the firewood and ash and cleaning, and the propane was starting to get embarrassing. So we went all electric, and it's also easier to measure than what you're doing. Replace that last bit of space and water heating with active solar by doubling the thermal array size. We adopted the world's most efficient cooktop and pots. And as we speak, those are both undergoing yet another stage of evolution. When we took out the living room wood stove, that left a flue that we are now turning into a light tube for better daylighting. And now we're about to switch out our rarely used electric clothes dryer to a heat pump model to see how that works. Our lighting systems have been repeatedly retrofitted, doubtless to continue. Same for the photovoltaics. as Mark rightly suggests. Our glazings have evolved through 5 generations in 42 years, going from center of glass insulating values of R5.3 to typically around 14, and in some units about 20. So that's equivalent to about 16 or 22 sheets of glass, but looking like 2 and costing less than 3. And we continue to experiment. Our latest greenhouse units use vacuum glass from Japan. There are several American firms entering that market now. And then a Ukrainian-American professor in Boulder has made us an experimental unit with extraordinarily efficient and nearly invisible aerogel. But fortunately, we took seriously at the start Stuart Brand's remark that every building is a forecast, every forecast is wrong. So designed for flexibility, like all our wiring and plumbing is in a chase, more or less running the length of the building so we can change stuff without having to get out a jackhammer. Now, let me give you a sense of how integrative design and technology keep improving through 5 simple examples showing energy intensity in green and its percentage reduction in yellow. So we used integrative design in 2010 to retrofit the Empire State Building. Many of you will remember that saved 38% of the energy. By now it's up around 49 with a 3-year payback. That was thought pretty good until 3 years later, when our cost-effective Denver retrofit saved 70%, making this half-century-old difficult federal complex more efficient than what was then the best new U.S. office at NRO. And that in turn is only a third as efficient as RMI's net positive no mechanicals innovation center, 10 minutes down the road here in Basalt, Colorado. By the way, in milder but cloudier Seattle, the Bullitt Center uses about that much energy, 38 kilowatt hours per square meter year. And now there's a Bavarian building using 2/5 less than that. By the way, those 3 figures are all gross intensities before you count the rooftop solar production that makes those 3 net positive. And yet, notice that all of these technologies existed over a decade earlier. What mainly improved doubling the potential efficiency targets for new and old offices in 5 years wasn't technology so much as design, the way we choose and combine technologies. So don't think it's only about the hardware. Of the 20 most efficient commercial buildings in North America, that RMI Innovation Center is the most efficient we know of in the 2 coldest climate zones. It uses about 1/9 the normal amount of energy. It's 1/10 bigger than your center and 16 years older. Younger, I should say. We moved in 2015. And like my house, it's passive net positive and essentially no mechanicals, just some air-to-air heat exchangers. It keeps people cool by 11 and warm by 10 passive methods. My favorite space is the Nega Mechanicals room, about 270 square feet, where I want to sneak in one night and outline on the floor in yellow industrial tape like bodies at a crime scene where the boilers and chillers were supposed to go before we designed them all out. And we expect this building's cost premium and under 4-year payback would drop to about 0 with wider experience, just as happened in Germany's passive buildings. Lots of interesting features, quite a few of them are potentially retrofittable. And I mentioned this Bavarian building. Our innovation center was the first passive house premium in North America. This is the first in the world in southern Germany. What's interesting here is the rooftop solar cells make nearly 5 times as much electricity as all 3 stories use. Makes you wonder, could about a 14-story building this efficient in a Chicago or Boston climate, kind of like Oberlin, be entirely powered by its solar roof without even putting PVs on the walls and windows? Well, easy to find out. And of course, the more efficient your building is, the more easily you can make a net zero or net positive. And now for opaque walls, we have the Dutch Sprung super outsolation technique, scaling in 6 countries and often bringing old masonry buildings to net zero performance with extended life and comfort. Now, it's a long time since I visited your campus, so I don't have the recent performance data handy. I apologize, but it was interesting to read that originally your site energy use for the center was about 30,000 BTU per square foot year, a bit over half of that going to mechanical systems. Well, that's nearly what this 4,000 square foot house office research center was using. Probably now we're using more because there were 5 years of pandemic and supply chain screw ups getting the last greenhouse reglazing done. So we're still waiting for a new blower door test and recalking this spring. So we have substantial air leaks that may be doubling our electricity use, but we're still net positive, and that includes a couple of EVs thanks to 18.5 kilowatts of rooftop PVs. But so you started 30, or once you switched out the boiler for a heat pump, you ended up with a net of 14 net. Again, in the early days, I don't know now. And we were about 8 when you built. And of course, net positive once we count our rooftop PVs. That Bavarian building was 21, 8 of which were for heating, but way net positive. The Innovation Center down the road a few years ago was running at 11, but still a lot of commissioning to do to run it according to design intent. And it's a large net producer. And generically, just for comparison, the state-of-the-art new office, really done right, is running about 6 to 12. So you can see that things have been progressing a lot. Now, I want to give, and by the way, one obvious question then is whether we could about eliminate your space conditioning loads by a thoughtful retrofit. Why can't the building be all passive like the next 3 here in a similar or harsher climate? And also, once your existing or improved rooftop PV would suffice, if the center isn't yet wired resiliently, maybe it should be so it works even without the grid or the on-campus distribution system. In other words, I think reasonable energy goals for a good retrofit would include net positive and not dependent on grid power. Let me quickly mention that everything is progressing. So I would hope to get rid of any compressor-driven mechanicals, but just be aware that in Singapore for 20 years now, Eng Lok Lee has been tripling the system efficiency on the design day. And about 4 years ago, I asked him how much better he could do. So he redlined and found that factor 3 improvement could now be about a factor 5. And well, what's next? Well, first of all, about half the remaining cooling system power in Singapore could be saved by underfloor displacement ventilation, plus a passive latent heat exchanger, which might be a good idea in your summer climate. It passively recovers the dryness of your conditioned exhaust air. It's not hard to do. And even more radically, delivering cool radiatively could probably cut your total cooling power to about 1,000th of standard practice with much lower capital cost. And let me just say a word about how that works. It's a really important innovation discovered by a Princeton team 6 years ago. They showed that outdoors in Singapore in January, which I think is worse than Oberlin in August, they could keep people comfortable in those tropical conditions without drying, cooling, or significantly moving the air. Instead, they cooled people almost purely radiatively, plus a little natural air movement, by absorbing far infrared radiation from their bodies into vertical panels subtending a big solid angle and cooled by a dense capillary mat circulating slightly cooled water. And the back of the panel is insulated and painted white to reduce unwanted solar heating. Then to prevent convection to and condensation from the ambient air, the front of the panel is shielded by an air gap 50 micron polyethylene film that's transparent to 82% of the infrared that your body radiates. So with muggy, nearly still ambient air at 85 F, comfort required supply water at just, I think it was 75 F or thereabouts. So people inside this walk-in pavilion about the size of a bus stop shelter confirmed that they felt comfortable using classical comfort theory measurements. They had to extend the psych chart to show the result, but it turned out that mean radiant temperatures from the water around 73 to 77 F could deliver comfort up to 90 F ambient at 80% relative humidity. Now, of course, radiative cooling, typically from ceilings or beams, is common in today's most efficient buildings, but it was previously thought to need tight control of indoor humidity to prevent condensation. This demonstration shows you need only keep humid away from cool. Little plastic film does that. And air handling in a radiatively cooled indoor space can then depend just on ventilation and health, not on cooling. We did that trick also in our innovation center, so the ducts got 4 times smaller. We're only delivering fresh air, not cool air. Much less airflow, energy use, noise. This may be the biggest discovery in comfort since Willis Carrier invented refrigerative air conditioning in 1902. And of course, if you want to feel even cooler, good ceiling fans can now get you another 9 to 13 F of comfort range. So without going into detail on all the international benchmarks we've assembled for performance targets, I think it's clear there's a lot to do. And that also means sweating the small stuff. Europe has 120 million pumps circulating hot water in houses, and they're 5 or 10 times bigger, 4 to 8 times less efficient than they should be. Many run all the time. They use 15% of the home's annual electricity, but now you can make them efficient, right-sized, self-controlling, and that would save 1/6 of Europe's Kyoto obligations, 8.5 gigawatts of power plants. And I even wonder about your efficiency of using and producing hot water. This little fist-sized heat pump at the upper left, a Swiss innovation, can produce 6 to 15 units of hot water per unit of electricity. And some early models on the right are nearly that good. Even though your daylighting is very good, I expect there's more room for improvement in lighting equipment and controls. And I wouldn't be surprised if your energy use intensity could get down in the single units of barbaric units with even better comfort and occupant satisfaction. That would be a wonderful demonstration experience, source of rich pedagogy, especially if it spawned continuous improvement and not just a quarter-century retrofit. And I wonder, maybe you've done this already, if you can increase your indoor junglification in line with what we've been learning about biophilic design from Bill Browning and others, this wonderful new book, Nature Inside. At our banana farm, the iguanas, snakes, African pygmy, hedgehog, singing frog have died of old age. I've been too busy to replace them yet, but you may notice a bunch of friendly fish along with our meditative family of taxidermically challenged orangutans to cope with banana emergencies when all 6 trees fruit at once and suddenly we have a quarter ton of ripe bananas. Happily, our orange family has not yet learned spearfishing like this wild friend in Borneo, but at least if you fall in the pond, you can get a helping hand out. So what next? You know, my information on the current status of your center is really old and sketchy, but my impression from afar is that you're blessed with a unique, brilliantly conceived, expertly executed, widely acclaimed aging asset. And based on our experience here with the banana farm, now 41 years old, my bias would be to build on what you got and with strong student engagement, make it a living lab of the latest and best practices, not just catching up with today's state of the art, but setting up to improve continuously into your long future. There is no end to the improvements you can keep making and the value they can continuously create for your mission, your community, and world. And you're really fortunate to have that opportunity. Thank you.
Can't really do a follow-up act on that one.
Sort of a mic drop.
You've left us, you've left us a little speechless on this end.
Yeah, I have a question, Amory. Thank you so much for this, and thank you for the Stuart Brand quote. I was rereading How Buildings Learn in preparation for this meeting, and thinking about the relationship that you have with your house and what he writes about in that book. I think is very helpful for this group as folks who live here and work in this building think about their relationship to the building over time. So I wonder if you could share with us the highs and lows of living in your own experiment, and what you feel like is the best way to maintain a copacetic relationship with this part of your life as a building. Do you find yourself breaking things down before you know how you're going to fix them again? Do you how do you have a love-hate relationship with it, or do you think it's always been sort of
Judy, who's sitting over here, and I love the building. It has it has occasional frustrations, mainly because we're so busy doing other stuff that it's sometimes hard for us to focus on the next thing that needs fixing. There are things that need fixing, but I keep telling her there's a lot fewer than in a normal house because, we don't have the mechanicals that would break, and the failure modes are pretty graceful. Our only catastrophic scenarios are if an elk falls through the greenhouse roof or wildfire, because the homeowners association just took away our fire hydrant up the hill, or if water gets loose on the hill above and there's a huge erosion event. So we try to figure out precautions against those. So at any given moment, we have several projects in the air, usually moving slower than we expect. But then again, we don't have student power, and it's really hard to get craftspeople around here. They're all really busy, and it's a short building season and so on. But it is a lot more beautiful than some of you will remember who visited years ago. Judy's done an amazing job with the aesthetics as well as the functionality. And I think those two questions she asked were really critical to getting us on the right track.
Yeah.
Well, no, I'm sorry, I have a question. Although it did not easy to do, trading out and renovating, replacing systems is in many ways easier than doing the same for the envelope. Unfortunately, I think we have a pretty good envelope, and with the improvement of the windows, and probably replacing them all at this point with higher, much higher performance glazing. What else could we be doing to the envelope while maintaining the integrity of the building? Do you have any thoughts on that?
Well, I don't remember the design and spec well enough to really give you an informed answer, but certainly you could get center glass R in the roughly 14 to 20 range. You could get it essentially perfect in letting it lie without heat. Bill, what do you have?
So as I remember, the connection points in the greenhouse section of the lobby, there's not a thermal break in that envelope. Right? The way the connections were done of the glazing to the structure was not gasketed with a thermal break. And so that's one place to take a look.
There are much better systems for that. All the details of sashes and how you mount glazing have undergone major improvement. Good point.
Good, thank you.
I did want to make sure before Amory left that Amory knew that the gentleman who was on before was the mechanical engineer that designed the RMI Innovation Center, Mark Bruni, with PAE. So he was just with us getting into some of the nerdy specifics of heat pumps and such.
Yeah, I'm glad he's involved. One interesting or two interesting stories though. A lot of the piping in that RMI Innovation Center has elbows that shouldn't be there because neither his firm nor we got around to instructing the installers before they had done their work. Oops. And then we had a near miss because we put in interface carpet tiles that were supposed to go down freelay with tactiles to hold the corners down, little gecko technology discs. Well, I caught it just in time. It turned out the company installing the carpet, although it was an interface dealer, didn't know that system and they were about to glue everything down. We only discovered that by accident.
Oh, geez.
So both those stories suggest a need for very careful coordination with your installers of every kind to make sure things don't get screwed up, even though if they were designed right.
Absolutely.
Henry, one thought, you're now at Stanford. And the question comes up is how do institutions manage this kind of design and technological savvy? Any thoughts about how you incentivize the work to continually innovate?
Well, Stanford has a very large and intricate bureaucracy, which I don't begin to understand. There's some important new leadership in the Durr School of Sustainability, but they have a lot on their plate, and it's hard to get them to make decisions about simple things like how do you design things. They are designing a 3-building, 15 acre new complex, and I'm trying to get into some ideas into that process. One obvious thing to try is to reward their design professionals for what they save, not for what they spend. Performance-based design fees. But they have their designers, they have traditional ways of doing things, and it may be difficult to change. I think Oberlin's small enough, it's probably easier to change things than something the size and momentum of
We don't
Stanford.
have a bureaucracy here.
Well, at least you know them all. And they're probably in the room. If not, you know who they are.
Henry, one other question in going through the process, what would you suggest about making this important to other buildings coming up on roughly the same milestones?
Well, I think I'd probably say something similar about other buildings, except they may have bigger opportunities. Bill, you've been through hundreds, thousands of buildings. What do you think?
I mean, the newer conversation is really shifting a lot more to embodied carbon, right? As the conversation about getting to net zero or continuing to squeeze efficiency, is much broader now. And so the question we're encountering more is the embodied carbon, and can we offset the embodied carbon? And
Sounds like the old New England, use it up, wear it out, make it do without. You just keep the building going.
Right, yeah, and I'll show an example this afternoon that Pliny Fisk, I don't know, it was 20 years ago, had this little experiment where he said, could in my choice of the building materials wind up with materials that offset the carbon footprint of other things in the building? And he did that with a little cabin using mesquite because it's so dense to offset the steel in the window frames in the little cabin. We have a 400,000 square foot building that just opened that's doing the same thing, but on obviously a slightly larger scale.
Slightly.
Well, we're gonna do, Amory, thank you so much for joining us for a little bit today, giving us a lot of food for thought as we enter into our lunch hour here. So just thanks so much for participating. Really appreciate the insight. Yeah.
Yeah.
Thank you so
Amory,
much.
please share a PDF of the presentation with everyone.
Yeah, I'll send it along shortly. If you're correcting
Thanks
if
so
you
much.
type.
Thank you, Amory.
Thank you.
Thanks.
Hey,
Thank you.
Bill,
Thanks
we'll
for
see
all
you a
you're
little bit
doing.
later. I'll sign off Zoom for now and then we'll be back up.
Okay, thanks.
Take care.
Bye.
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 So I just